All right, welcome everybody. Today is the 26th of October in Dallas, or the 27th of October and around the planet. This is Dallas Personal Robotics Club, Robot Builders Night or afternoon, and we get together and talk about robot-y things. I'm Carl, the current president, and what we'll do tonight is just the usual, go around the table. We are recording these, so you can mute or not speak if you don't want to be on the recording. Tonight, we're going to start off with Ray has an update, and then Pat, then Chris, then Murray, then a free-for-all. So, Ray, what have you got?
Okay, let's see. Gotta go back. There you go. Okay. Okay, this is can you see that video?
Yes.
This is not moving, but you can see the screen, right?
Yes.
Okay. Anyway, the pattern, the video that I showed last week with the pattern on the garage floor, that I, basically clipped a pin on the one side of the frame and drew a pattern. I've basically ported that over to the bigger platform, and so now it's, struggling with the grass and the uneven ground and all that stuff. And so basically I have, wheelchair motors on either side. They're running off 24 volts. Up on this aluminum mast, I have an OLED display and a B&O 055. And in this box here is a RoboClaw 2x60 motor driver, and then one of the LoRa ESP boards. So I tried to basically, port everything over it, to this platform, and just, do a trial run and see how it works. So this is the trial run.
Audio is kind of silent or quiet.
Better?
Yeah.
Ray, are you remote controlling that, or is it autonomous?
It's autonomous.
Huh.
Bravely standing in front of it.
Well, I took the deck off to get it out the door, so, and the gas engine's not running, so.
No blades.
Does it have blades attached?
You got encoders on the drive wheels?
Yeah. Yep.
It's pivoting on its wheel,
And is this a proposed kind of cutting pattern if it's following?
Yeah. So and I had to stop it here because it was probably going to run into the tree.
I don't know if you can see the marks.
Pretty repeatable?
Sort of.
Yeah.
You can see
Yeah.
it.
I don't know if you can see them here. There's like
Okay.
one
Anyway,
here
okay. Stop.
and another one like here, and this is where it turned on the other one. So basically, I wanted to just, basically simulate how we would mow, or I would mow. I'd push it down one lane and rotate it on one wheel, and then come back and then rotate it on the other wheel, and so it would cover this pattern, and it's following it, being guided basically by the compass and odometry, so it can do that pattern. And that was the same pattern that it traced out on the garage floor with the smaller mower. So it does really well. The distance between these two wheels, it's a 42-inch deck, and the deck sticks out further than the wheels, probably by 6 inches on either side. So this would be kind of a wasteful pattern because there's too much overlap with the deck. But if the wheels were either further apart or if I changed how it rotated, then I could make use of it. You always want a little bit of overlap, otherwise you may leave a strip of uncut grass there. But turning on a wheel really overlaps about 6 inches per side, which is way too much. Anyway, the other platforms, let me get back. I can put wider wheels on them, or separate the wheels. So like if I do it at a meter, which is kind of a convenient measure, I think a meter is what, like 39 inches or something. So a 42-inch deck, I'm gonna have a little bit of overlap on each side, which I probably can't. I'd have to have that, like I said, otherwise I'm gonna risk leaving strips that aren't mowed or something. So anyway, just wanted to show that. That was it.
That's it. That's the first gold star. First one out of the chute. Look at this. How about that, man? Yeah. Nicely done. No groundhogs were sliced in the making of it. Cool. All right. Pat, I think you might have some news from Canada.
From up north, yeah, no snow yet, which is good.
All right.
I'm just going to show you what I've been working on. And so can everybody see that?
Oh, yeah.
So that is my latest attempt at a motor driver. So I used a knockoff Pololu VNH 5019 motor driver. And then I've used an STM F103 blue pill board. And I have right here, I don't know if you can see my mouse, a little 4-channel level shifter. And then an adapter board I made for the encoders. So I've got all of this soldered together. Basically, that I don't know why it came out looks crooked. It isn't in real life, just from my phone. Just what I've been working on there, and then the other thing I've been doing is working on free RTOS. So I've been I actually signed up for a course on Udemy. They had a sale. I think it was about $16 Canadian. It's about 30 hours worth of learning. And so I've been going through using free RTOS on Arduino. So I've been doing it in I'm using Arduino essentially frameworks, but I'm doing it in Platform IO. So there's slight modifications, but it's working well. I'm about a third the way through the course, so I'm trying to get it so that the routines take care of themselves. Instead of right now, I do it as almost a state machine. So when I receive a communication, I jump and do some stuff, and then I send off some communication back. And what happens is if communication gets a little bit mixed up, I get out of sequence. And it's my interface with Python on the Raspberry Pi that gets a little bit mixed up. So what I'm looking to try to clean that up with the real-time OS is that I can be constantly transmitting my data from the motor controller. So my battery data, my current on my motors, my encoder pulses can be continuously updated independently of the communications coming from the Raspberry Pi, which is my speed and angular coordinate data. So basically, it would split the two tasks off into separate entities, essentially.
That sounds cool. So you recommend this course? It's pretty clear.
It hasn't been bad. It's at times I find it's a little bit The guy makes mistakes going through the course, and I think sometimes he's correcting the mistakes where you don't see quite off screen, because you can see spelling mistakes that are made in variable names and stuff like that. But then all of a sudden they're corrected and they're working. Overall, it's been pretty good, and he's really good at explaining the concepts of the free RTOS system. So you get to know why, why, how. And there's a lot of repetition. So basically, hey, wipe out the program. Let's make the next program. So you're always building on what you've done, but you're always wiping it out and starting over. I'm about a third of the way through, and it's been good. For $16 Canadian, I don't know what they would charge for. It's a US website, I believe. I don't know how much they would charge, but the courses go on sale, so it's regular like $125 Canadian course.
Yeah.
And all I did is I signed up for created an account, and I wanted the course, so I put it in my cart. So I saved it, put it in the cart, and then you wait for the email to come by, say, hey, there's a sale on, and it's going to be this much instead of $125, it's $16.
Yeah.
It's a heck of a sale.
Yeah. So
It seems to be the way I think that's the way they normally run. Like the U.S. Standard sale price seems to be $11.99.
Yeah,
something like that.
And overall, I've done a couple different ones, and overall, I find that they're good.
Yeah, well, maybe if you could put the link in the chat, that'd be cool. For a known quantity.
How much is that?
Can you speak to what free RTOS on Arduino means? Because Arduino can be an IDE, it can be a family of boards that could be 8-bit AVR based, or possibly some of the 32-bit processors, and it can be the set of libraries. So what does that actually mean?
Okay, I'll share my screen again, and I will show you what I am doing with that. So I don't know if you can see that.
Yeah, I can see it.
Get rid of this guy. So basically, it's an editor. So I'm using VS Code, and on top of VS Code, I'm using Platform.io. I don't know if you're familiar with Platform.io. And what Platform.io does, one of the features I find is really interesting, is that if you're in the Arduino world using the Arduino IDE, when you update a library, you're updating your library for all of your projects. So when you're updating a library in Platform.io, you're updating your library for, you can install it globally, or you can install it just for the project. So that's one advantage. So when I go into my project, go back to files.
Sorry to interject, but Paul, one way to answer your question, I mean, this takes the place of the Arduino IDE. Okay, this editor takes the place of the Arduino IDE, but behind the scenes, because like you kind of said, Arduino means actually a couple things. It means hardware, it means IDE, and it means framework or API. This takes the place of the IDE, but behind the scenes, he's still using the Arduino framework or API. So he's still using the function from the wire library and, digital in, digital out, and I forgot what the APIs are, right? So all those APIs he's still using, because this is using the Arduino framework, right? And
Thanks. I understand that part. And thanks for confirming my understanding. But I was really probing on the free RTOS is presumably a library that provides some APIs to like create threads and mutexes and that kind of thing. And so is it a library that, oh yeah, I see, you include the free RTOS.h, and that provides access to all the APIs for the RTOS.
Yes.
Nice.
So if you go into
someone has packaged it up as an Arduino compatible library. When I say Arduino compatible, I mean Arduino framework compatible, so that you can use it, inside the Arduino IDE, or you can use it inside of here.
Thank you for that explanation. That answers my question.
Okay,
And
so on the left, you can see I've got all the routines from the free RTOS are in there. I don't know if this goes into any details. It breaks it out into other things it's using as well. So basically, it's Arduino style C code everywhere, and then so as you can see, there's my environment. It's a Blue Pill F103. The platform is an STM32 processor series. The board I'm using is a Blue Pill F103C8. The framework is Arduino. So I'm using essentially the same language as Arduino. And then you go
What else could that? I'm sorry. What else could that framework be?
Oh, with the anything you want it. So if you're for different framework,
But it's not anything you wanted. There are like 6 choices, maybe.
yeah, it depends what you're working on, but you could be working in Python instead of, for your computer. You can be developing in C++.
So that framework would say C++ or?
No, it has specific. So Arduino is one. Then there's another. Is it called Zephyr or something? There's some other RTOS kind of environment that is packaged up as a framework. Then there is even on the STM. If your hardware is STM32, you can use that API that you get with STM. You can use that. You can choose that as a framework. The STM32 HAL API that you would use if you were using the STM IDE. So that's also available as a framework. And I forgot what some of the other options are. Yeah, if you pick an STM board, you'll probably get a couple choices there for framework, at least 3. Just pick any STM board.
STM
Yeah, all of them are STM. So now you get a couple choices there. Your embed. Okay, yes, Semsys, that's like a standard RTOS kind of thing. STM32 Cube is the one I mentioned, and then Zephyr RTOS is the other one that I remembered. Yeah.
Yeah, Zephyr RTOS, STM32 Cube, libopen CM3, standard peripheral, CM, SIS, embed, and Arduino is what they're using for this one.
Yeah, libopen CM3 is like CM3 stands for Cortex M3. So someone put together a library, in device drivers that'll work on a lot of different ARM Cortex M3 and M4 type devices, and so you can use that API, and build on top of that.
Yeah, so if you use the STM32 Cube, I think it'd be closer to the GCC you're using, David.
And just to clarify, out of the box. Oh, go ahead. Sorry, David. I just had a quick question. Are you getting dependency management out of this as well then?
When I install everything, when I create a project and install it, it loads everything I need. So then if I need a library, I go to the library manager and I don't know, pick one. So I want a VLX. What is it? 53?
Yep. L1X.
L something. So I do a search. So basically, it's coming up with nothing.
L1X.
L1X. I'm surprised it's coming up with nothing.
Do VL53.
Mine says L1, just VL53 L1.
VL, not VLX.
Ah, that's why.
Yeah. There you go. Nothing. I don't know why.
Yeah, I found the search for libraries sometimes to be a little weird the way it works. Sometimes too many characters are a problem. Sometimes too few characters can be a problem. So that's a little quirk.
It could be that it's only doing libraries which match the other criteria you put in.
Yeah. So right now I am.
I guess I get the point though, Pat, that yes, you get dependency management, which is a big deal. That's good.
So there's all the libraries. So is it VL53? Try this again. Nope, no results for that one, and it should be because there was one listed earlier.
Yeah, the search is a little weird. Like I said, sometimes it doesn't like it if you put too few characters in there.
Try VL53L1.
VL53L1. There it is. So now you come up with a bunch of different libraries. So 2 different libraries it's got here. So one of them will work with ST and STM32. The other one is ST and STM32. So I don't know why there's no Arduino library for it.
It's the top one is the Arduino.
Usually it'll say Arduino on it. Oh, it does
Yeah.
here. So it's Arduino framework.
Yeah, and the bottom one is the
So
other one.
when you select this, I can add it to a project or I can add it to globally throughout. Which is, I usually add it to a project, which means that I don't necessarily have to update it, or I can revert to a previous update if there's an issue. It's something I found I like a little bit better than the Arduino.
A lot better.
Or last August was my get bogged down and it becomes really unresponsive. If I take the video routine out, it's working actually quite well. So I've just got to debug, figure out what's going on with the video routine to see if I can get that working.
What does the video routine do?
It's the video, it was spotting an orange traffic cone.
Okay. And you're saying, is the video bogging down everything else, or is the other stuff preventing the video routine from doing its work?
That's what I'm still got to figure out. So I've got to do some more troubleshooting. And I think it was Doug that pointed it out to me. He says, hey, you got a turntable? Stick your robot on a turntable, stick an orange cone in front of it, and then you can spin around your robot and see what's happening. Doug told me that during the contest.
Yeah.
And unfortunately, I didn't have enough time to troubleshoot it at that point. I'm working on it for 2022 too.
One thing, if you have an issue with things getting bogged down or something preventing other stuff from running on the Raspberry Pi, you may want to familiarize yourself with sort of how to set priorities, because if you just run stuff out of the box, everything runs kind of not even at a priority, just at some nice level, sort of the legacy, Unix terminology, and everything competes, and everything is getting scheduled under what Linux calls the completely fair scheduler. It just does the best it can do, right? But it doesn't know what's more important. Everything is equally important, okay?
Yeah.
So you're talking about having FreeRTOS on your blue pill. Well, on the Raspberry Pi, unless you tell it what's more important, it won't know. And then certain things may not run in a timely fashion, right? So your video stuff is probably the biggest time consumer. So you may want to just leave it as is, start it the way you do right now. But those other things, you might want to consider starting those and deliberately running those at an elevated priority, right? So at least they won't get slowed down by the video task, which, who knows how long the video processing takes sometimes,
So I don't think my video task was slowing down the other processes, because as I was steering to the right, trying to correct, but it wasn't getting it, because it spotted the cone, issued a correction, but it just kept correcting. It never stopped correcting. So I think the video was stopping to send updates, because as it was getting towards the garage, I told it, wait till you're about 6 inches away and do a hard turn, a spin to the right. And that's what it did. It saw the garage, and 6 inches before hitting the garage, it does a spin to the right and stops. So that part of the routine was working perfectly fine. Otherwise, if it was bogged down, I would have ran into the garage.
Okay.
So,
Cool.
Are you saying garage?
garage, yeah. I was testing my backyard
Oh.
garage. Garage?
Ray. All right. Well, that's cool, Pat. Lots of progress this week. So now we see what happens as we go from the retired crowd to the not quite yet retired crowd. So not giving away names or anything, but who's next here? I think we had Chris and then Murray in the list.
Yes. All right. So let me do the sharing thing. Let's see what I want to share first. How I want to do this. Okay. So let me. So last time I showed, if you remember, I showed some of the RAW's navigation stack, as it's called, so the capabilities with, you know, obstacles getting highlighted on the screen, and you know, I issued navigation commands, and it was trying to, you know, find a path to the destination and then go there autonomously. I mentioned last time that I have to still incorporate the ultrasonic and infrared sensors that I have on my platform, and so that's what I have now. I have those, you know, I had the LiDAR all, you know, going on and showing data, but as I mentioned, there's some clutter in my room and stuff in my room that the LiDAR just doesn't see. Okay, and that's why we have, you know, the ultrasonic sensors. You know, they do pick up things that the LiDAR misses or that the other sensors miss. So I have those incorporated now, and I just want to demonstrate in the second. Not navigation. I don't have that today. I don't have that information yet fully integrated, but I just want to illustrate one of the cool things that RAWs can do for you, even if you don't care at all about the navigation stack and all that stuff where it gets a little complicated. And I've mentioned that numerous times, just the visualization that RAWs can do, you know, and help you understand what your sensors are seeing. So I'll illustrate that. But to do that, let me first show kind of the use case. Window or screen, blah, entire screen. Okay. Okay, let's see. I want to switch to here. All right, I don't have the camera pointed at the floor, but basically this is my Romy. This is what it looks like when it's on the floor, and it's going to look at some obstacles. So we're going to see in a second what that looks like, you know, visualize, you know, that information. We'll see that in a second. But the thing I really wanted to show is this is sort of one of the use cases for me where I need something in addition to the LiDAR. The LiDAR, as good as it is, it just won't pick up this bag here, the black bag right in front, you know, of the robot, you know, so that the front is where the bag is. So as you'll see in a second, this bag, all this black here, will not get picked up by my LiDAR, right? And I have a couple other things that kind of fall into that same category, you know, right? And that's, well, we know that that's going to happen. Same with infrared sensors. You have these limitations, and that's why we have the sonar, okay? So now, let me show you what that looks like. So back to sort of this, I have this set up right now, and I'm going to pull up the RAW's visualization sort of screen. And what's going on here right now, let me just walk you through so it's not too confusing. The circular thing here in the center is represents the robot, okay, and the black dot on top is, well, actually represents the LiDAR. I can show that in a second. I've actually put in a little bit of time to, I wouldn't call it creating a 3D model of the robot, but just about as primitive as it can get. Just, you know, a couple disks to represent the correct size of the robot and the LiDAR. But so this is just so I can orient myself when I have a screen up like this. So the yellow narrow cones represent the 3 infrared sensors that I have, okay? And you can, again, it looks approximated like this. This was from earlier. It's, you know, I've it lined up so everything is hitting that target just to make this demonstration a little easier. So you can see my infrared sensors are picking up an obstacle. The red dots, well, they're really lines because the dots are connected, right? That's the LiDAR. You know, in most cases, you can consider the LiDAR to be the ground truth. It will miss stuff, but it's pretty good. And you can see how my infrared sensor is picking up, you know, obstacle right there where the LiDAR is picking up this little cardboard box, and the same for everything else. Again, there are some infrared sensors are not perfect. I do have them calibrated to some extent, but you can see right here that yellow cone in the center, you know, doesn't quite line up with the LiDAR, but you know, you can only expect so much out of these sensors. And the gray cones, which are much wider cones, right? They represent my 2 front-facing sonars, and I don't have them angled right now. Right now, they're just facing just straight. And what I have done is, in a manner that RAWS wants you to do it, I have told RAWS, you know, where all these sensors are relative to the center of my robot, right? So I had to tell it, look, there is a sensor. It's at the following X and Y coordinate relative to the center of the robot. And it's, well, in this case, it's the sonar is looking straight ahead. Or in the case of this right-facing infrared, right, again, it's positioned on some XY coordinate relative to the center of the robot, and it's pointing in one particular direction. All of that is captured in a certain fashion, in a certain file, right? And now other parts of RAWS, right now we're just looking at the visualization part of it, can take advantage of that information, right, and present it to you. And again, what this is useful for is to just help illustrate some of the limitations of the sensors. Okay, so now let me just drive this thing around a little bit. Where's my black bag? Okay, I'm gonna remove the thing in the front. And well, this is helping me right now actually understand some of the shortcomings of my infrared sensors. I think the center-facing one is picking up a ghost here, right? It's showing me there is something, you know, 30, 40 centimeters out. And there's really nothing. I mean, the sonars are not picking anything up at that close range, but this guy's picking something up. So this guy's has been giving me trouble. Maybe it's facing down a little bit too much, you know, maybe it's tilted down. It could be pointing at the floor and picking that up. So I got to look into that. And, you know, this is one of those use cases for at least this feature of RAWS, right? It really helps you visualize what's going on with your sensors. So I'm driving towards that leather bag, okay? And I'm now literally sort of in front of the leather bag. I've actually come too close. You see my center cone went away. That's because, you know, they have a minimum distance requirement, those longer range IR sensors. Let me go back a little bit. Okay. So my ultrasonic and my front-facing IR is definitely picking something up. My LiDAR is actually surprisingly picking up something here because I'm probably at some angle. Usually it doesn't pick it up at all, but like I'm smack in front of this black leather bag, right? And the LiDAR just doesn't see it. I mean, yeah, it sees something. Let me move more perpendicular to the bag. Yeah, there's some dot on the left here. I don't know what it's seeing there, but there's literally a big black thing in front of my robot, and the LiDAR is not seeing it. Well, and that's why I need those sensors. And that's why I need to sort of visualize this. So So go ahead.
The bag has some things like a little chromium fasteners and so forth, which you will get a reflection off of. I wonder if that's what that dot is.
Yeah, they are a little higher. It does have that. They're a little higher. So, but you know, because it's not perfectly flat, it has some curvature to it. That might change things a little bit. So now I'm just pointing straight at the door. You know, this is obviously a real easy scenario, but you can see that my sensors are, at least at that very close range, they all give pretty good readings, right? And you can see they are, you know, somewhat calibrated. My infrared sensors pick up an obstacle more or less exactly the same distance as the LiDAR picks it up. So again, that's kind of what I can use this to sort of confirm that. And then as you get further away, they become less and less reliable. So, you know, I can use this to sort of help me decide, you know what, beyond 1 meter out, I might not even, you know, look at any of these sensors because they just become so damn unreliable, those cheap ultrasonic sensors and so on. But again, this is just for visualization now, but so the next step from here is to now feed this data, right? And that's where it's sort of the power of RAWs now becomes more apparent, is because I have told it where those sensors are, which way they're facing, what their limitations are, kind of captured that in a certain manner. Now when I feed that information into some parts of the navigation stack, it can now sort of construct this obstacle map, right, or what's called a cost map in RAWs, and then it can use that information, you know, for navigation purposes. So the point really is, and I don't know how good that would be if you only use that, but if you did, you know, typically people use RAWs because they have sophisticated sensors like a LiDAR or a depth vision, you know, something like that. But my point is, actually, even with the more primitive sensors, if you set things up correctly, you can build up some of these, you know, cost maps and those kind of constructs that help you either, you know, create your own navigation algorithm, or, you know, you just leverage the sort of the, you know, the ones that are quote unquote built into RAWs, right? So that's kind of the power of it, right? You tell RAWs everything there is to know about your sensors, all this metadata, and once it's there, right, it can be used in a variety of different ways by different parts of different, you know, features of RAWs and different modules. So
that's really neat. A question. You've presumably modeled the robot in URDF, and you're using that. And I'm familiar with the ray sensor, but as far as I know, the only way that I've used it is as a line, a single line of a ray. I haven't seen that conical sensor. Is that a ray sensor, or is it something else?
Okay, let me put presentation back on for a second. It is, so RAWs, and I don't know at what version they introduced this, but they've had this for as long as I know, is it has okay, it has this notion of a range sensor, okay? So that you see these things on the left side, all these different pieces of information I'm displaying. Well, much of it is turned off. And not really relevant.
I see the IR left and center, right? US ultrasonic.
Exactly. So let me see, how do I explain that? Okay, this doesn't show much. This just shows the name of the data point that I'm displaying, which is called IR left. But the message type, or the sort of native data type, so to speak, that RAWs has for this is designed to capture, it's designed to deal specifically with infrared and, I'm in the wrong place here, give me 1 second. It's designed specifically to deal with infrared and and ultrasonic sensors. So they have created a specific data type for it. And when you as you publish the message, you can say, and I'm just pulling up Visual Studio Code here, which we've seen earlier. I just want to point out one of the cool features I use. I'm actually editing now the files on my Pi, so this is kind of the remote feature of Visual Studio Code. It's one of the best features. So it has. Let me go.
I see the range dot message has a field of view field.
Yeah, so I'm just oriented myself. Where is my stuff? It's okay. So where am I publishing it here? Okay, so I'm publishing a message of type range message. Okay, and you can see here it allows you to capture some metadata, such as what type of sensor is it? Okay, ultrasound. What's the field of view? What's the maximum range? Ignore everything that goes above that. What's the minimum range? Well, what's the actual range value and timestamp and sort of some of the more usual stuff. But so it has a built-in sort of notion of infrared and ultrasound sensors, and the part of ROS that then takes this information and incorporates it into an obstacle map or a cost map. It's a way it knows that this information needs to be looked at differently than what's coming out of a LiDAR. You can take a LiDAR very much for granted. If you get a reading, there's something there. Well, you might not see something. That's another matter. But with these IR and and ultrasonic, you're more likely to pick up some reflection where nothing is there. You can't. They're just inherently less reliable. So that they apply a bit more of a probabilistic sort of model to that information, and they incorporate it into this cost map differently. And again, at one point, I hope to sort of show that. I'm not quite there yet. But the point is, it knows that those sensors are different. They have a field of view. They have certain limitations. And again, all parts of RAWs kind of have this information available, and will use it in the appropriate manner. And yeah, to your question about the URDF, yes, so I have all these coordinates that I just talked about. Okay, here, where is my center IR? It's attached to my base at X, Y, Z coordinate like that, and it's pointing a little bit to which one's that? Oh, wait a minute. Oh, that's the right. Okay, some of the text is copy pasted. So this is the right facing. So it has a yaw of -1.
Yep.
Okay, so this is one of the standard ways you tell RAWs about your robot, what's attached to your robot, where is it attached, how is it attached. You can go crazy with that. In the past, I haven't really done that. I'm now appreciating this capability a little bit more, because again, this is really, once you have a couple sensors that point in different directions, once you got your arms around and how to do it, and you always start with examples. I started with an example here. I didn't have to create this from scratch. You tell it where your sensors are. Here's my laser. Yeah, my laser is at the center of the robot. That's easy. And it's turned 180 degrees, so that I had to tell it that.
So what you're showing here are the joints that between the robot base and the sensors, but you aren't showing the instantiation of the sensors themselves. So normally there'd be like a sensor instantiation as well, right?
So there is a link thing that represents the sensor. Yeah, so that's the other part of it. Yes.
And now, for LiDARs, the link name is normally has something associated with it. I forget.
Yeah, so the link has a laser, and then that becomes so there's these labels in here become quite important in some parts of ROS because that's how you tell something. Hey, the position of this relative to my laser. You refer to these labels.
That's interesting. I see what if I understand what you're doing here. You're creating a URDF that is the description of where these sensor links are, but
Yes.
you don't have a plugin, and it would only be when you go to use Gazebo that you need the plugin.
Yeah, I think your reference point is Gazebo, and there's other stuff going on when you're building this up purely for the purpose of simulation. You're right that there is going to be other junk in here that really has nothing to do with a physical robot.
Right. Okay, cool. Thank you for that explanation. I hadn't seen the range message before or used it, and I hadn't done it where you were using it for RViz display, but not for Gazebo. So thanks for explaining that.
And I don't even have visual representation of the sensors in here. Again, I didn't want to go crazy. I have a visual in here for the LiDAR, which is just a cylinder. That was the black cylinder.
Right.
And I have a visual for the tires, if you look at it from the right angle, and a visual for my double-decker base with just two cylinders, So very, very primitive 3D modeling, but really that I'm not using it for that reason. I'm using this mechanism really for sensor positioning.
Yeah, that's awesome. Thanks for the explanation, Chris.
Sure. So again, then to recap, the next step is, this is visualization. I can see the flaws of my sensor and get an appreciation for how well or not they work. But it only gets really interesting once I feed this information into some of the parts of the navigation stack that I showed last time. But I haven't done that yet. Other questions?
Just awe.
Yeah, this is really awesome.
It's just, again, it's more gold stars, right? Because we're moving robots around and visualizing it. So,
two thumbs up.
3 in a row. We're doing great tonight. Nicely done, Chris.
All right, thank you.
Yeah. And we trust you. We saw a photo, at least, of the robot on the floor this time. Not just smoke mirrors and simulators.
I need a faster computer so I can use OBS and switch switch video streams around. All my equipment is a bit underpowered. I'm due for an upgrade.
You'll enjoy when the time comes, but you're enjoying now, so. Okay.
Chris, I did have a question, and not specifically with Ross, but with communicating and doing Visual Studio remotely onto the Pi.
Yeah.
Do you have to have an account set up on both to be able to do that, or is it strictly like using SSH or something?
It's strictly using SSH. So yeah, you go in here. Well, you gotta install the remote plugin, right? So I have that installed. A couple flavors of it. So you have to have this remote-SSH plugin installed, which comes from Microsoft. Okay. And once you have that installed, you get this little green thing in the bottom left. Which initially it'll just be there. And that's where you click. Well, that's one way to sort of then initiate a remote session. See, that's what I mean. Now in the bottom left, I got this little green thingy, okay? So if I click there, and if it's the first time you're doing this, you have a couple options here. But basically you say, all right, I want to connect to a host, so use a Pi at some IP address, and then it's going to prompt you for, okay, what are we talking to, Linux or Windows? Then it's going to want the username. Oh, sorry, you gave it already the username, it wants the password, and it's going to install some crap on your Raspberry Pi, but that happens all transparently, and it's not a huge amount of stuff. Kind of installs the Visual Studio Code backend. And then once that's there, and that's a one-time thing, right? Then once you have a remote connection going on, it feels like you're just editing files that are locally on your computer. Okay, it's extremely snappy, and if you have all the plugins installed both locally and on the remote side, sometimes it's telling you, look, you've got a certain plugin installed on your laptop, but that plugin is not installed on your Pi, all right? So it'll tell you, hey, you may want to go ahead and install it on the Pi too. All right, see like here, Docker plugin. I thought I had it installed on the Pi. Maybe I don't have it in this version of VS Code. So you want to have the plugins installed both on the back end of the Pi and on your laptop, and then you get to tap into all these great Visual Studio Code features as if you were, doing all this natively on the Pi, which in a way you are, right? It just all happens transparently. Like, for example, you see down here, it knows that I'm running RAWS 1 version noetic on my Pi. So I can pull this up, right? It pulls up information about the RAWS subsystem stuff that's running on my Pi right now. I don't have a huge amount of use for this, but it's somewhat useful, right? So there are plugins for everything in VS Code, as those of you who've used it know. And with the remote feature, again, for those of us who are working with a Pi, but then doing work on a laptop, it's the only way to go. There's no way going back to anything else, as far as I'm concerned.
Yeah, so I think you clarified the one point I was questioning. So I need VS Code on both local and
you don't need the VS Code IDE on your Pi, although I have it there as well. But you don't need that. When you establish this remote connection through SSH, it will install stuff on your Pi for you, the backend. That backend that it installs is completely separate from the VS Code GUI, okay? So they have nothing to do with each other, right?
Okay.
I don't know if it's show hidden files. I think this is files on my Pi. No, it's not. It's basically installing files into some hidden folder here, .vs code or something, right? And I'm not sure I can find it now. VS Code server, there you go. So installing all these plugins that you're installing when you're in remote mode, all this crap goes into .vs Code server. That's what I mean by backend. So all that happens transparently. You don't have to worry about it. Whether you have the full GUI installed on the Pi is irrelevant. The laptop side of this will do all that for you, and then make it look like you were right there on the Pi.
Excellent. I think I'll give that a try.
I'm with you. I think about even maybe a little bit. So like one of the first options, I don't know if you all tried this, but I tried was Real VNC, where you basically export and stream a screen scrape from the Pi, and then you manipulate through the GUI in that way on your laptop. But I found that this is it feels so much zippier than that, and it would make sense because it's only updating a little bit of text now and then whenever it needs to change.
Totally.
And you get all the power and the speed and the memory and all the resource of your laptop, and all it's doing is making these small little manipulations to the file system on the Pi. So I agree with you completely, and also with like Git. So I can run all the Git functions from within Visual Studio Code, and then make commits and push it up to the cloud. So
yeah, exactly.
I've always used XRDP for connecting to the Pi from Windows. For some reason, way back when I had an unpleasant experience with VNC, and I dropped it.
Yeah.
Yeah, I mean, I use VNC sometimes. It comes in handy, but again, anytime you're working with a GUI and an IDE, it's just never as zippy as when the GUI runs natively on your, let's say, main computer. And like Carl said, the Git, I have all my files in GitHub. I have one big folder. I just threw everything in there, one big bucket of files. But at least keeps me somewhat, sane if I have to go back to a version. Like Carl said, all this is nicely integrated. I'm just showing differences, recent changes I made. Okay, here's where I integrated some of this new stuff. So there's a plugin for everything. You can look at binary files in hexadecimal. You name it, there's a plugin, and it's just, yeah. And again, the other thing is you have, where it gets real powerful, and I mentioned it previously, if you're doing Python stuff, right, and you're looking at Python code, and you're in remote mode, and that is one difference. If you're in remote mode and you're looking at Python files, you can debug those, right, through the Visual Studio Code running on your laptop, in this remote setup fashion. Again, it knows, because it's connected to this Visual Studio backend, there's a lot of stuff happening there. If you watch your processes on the Raspberry Pi, you'll see it. Sometimes it can consume a bit of CPU when you're doing stuff, so it's something to watch out for. But you can debug your Python code or whatever you have, right, through this IDE that's running, on your laptop. So it's real convenient and real good user experience.
And it's robust. And I just think it's so funny, right, that you have this really expensive laptop so that you can edit files on a really cheap, stupid little nothing processor by comparison. Oh, cool.
Thank you very much for that,
Chris. Man, you're just knocking it out of the park week after week. That's pretty awesome. Very nice. Thanks. All right. So next we have Murray up. And while Murray's getting ready, I think you wanted to go, Murray. Is that right?
Yep.
Yep. Okay. So whoever wants, we don't have anyone in the queue after that. So think about who wants to jump in while Murray's hitting the present button.
Oh, I don't actually, well.
Or talk button.
Do I need a present button? I don't know if I do. Okay, I got three things. Last time I was talking about, without getting into the whole ballistic thing, but basically the idea of being able to trigger a behavior that would eventuate in the robot's future. So that when you come upon an obstacle, it would then set up a set of routines that would then run sometime into the future. And I had gone ahead and implemented that, and I was calling it a macro, for lack of a better term. And I had got the whole thing implemented and running, and then I've basically in Python found out that it wasn't really working very well. That for basically you'd say, okay, I want to run a certain number of seconds this way or a certain distance for this, but what I was finding was that the way that I'd implemented it was actually really awkward. And I was literally loading the Python files dynamically and running them, which is tricky. But that means, though, that the Python file that's running doesn't really have access to the existing robot OS that's currently running. And so there was this awkwardness of trying to pass variables and things back and forth. And I finally just gave up on that. And the reason I had that is I wanted to make each macro into its own Python file. That was the goal. And what I ended up finding was that was just too awkward in the end. So what I've got now is a single Python class that now has methods. And each method is actually run as a macro. And that means that I just load that at the beginning, and there's none of this awkward loading dynamically and all that, which is a nice feature kind of. But in the end now, when a macro runs, it's running within the system. It's got access to everything that the system is running. It's basically in time. And in any case, I've rewritten it now, and it's now functional. And so I guess a few weeks ago, maybe even a month ago, I had demoed this idea that you could have the robot running forward, and then the center infrared, as you came close to a barrier, it would gradually slow down and stop at 20 centimeters. And so I can demo now. The robot's not moving. It's on the bench. So it's not quite gold territory. But basically, the idea is that the robot would be moving forward and slow down as it came up to something. And now what I've done is that the infrared sensor, the center infrared, was normally sending an event type of infrared center. But once it gets closer than a certain point of 15 centimeters, which is configurable, it changes that message from infrared center to bumper center. And it treats it like a bumper. So it's an optical bumper. And that triggers a macro. So I can show that part. So I don't have the slowdown configured to be on. So it won't slow down as it comes up, but it will trigger the macro. And you can see the macro running because there's a little light on the robot that changes color. So I'll start this up and turn this down. So can you see the robot now? Okay. So now if I say go forward, so it's now running forward, and I've got the little green lights that show up on the front. You guys can see that?
Yep.
Okay, so it's basically an LED that says, I don't know why we don't see two of them, but there should be two of them. That's actually a bug. Now, as I move forward, over there on the thing, you can see the messages popping up, and that's an infrared message and now it's actually triggered. Backup, has it? No, here we go. Oh, there it goes. Now, I'm close enough that it should trigger a bit slow. There we go. The blue is backing up. It does a maneuver, and then at the end of that, it re-triggers. So what it's actually doing is saving state. I think I've got a bug. It's not coming out of that mode. There it goes. There. What happens is that at the end of the macro, it saves the state and the direction that the robot was moving. I might have a bug here.
Yeah, I think I saw green and blue at the same time.
It looks like a bug.
We never see bugs in demos.
There it backs up. There it backs up. But I think it's not supposed to run that long. I've got a bug. Oh, well. In any case, I almost have it running. In fact, it's... Okay, anyway, that's in progress, I guess. No gold star. But the idea there is that the infrared center, the center infrared sensor, normally after a certain distance treats it as an infrared, and it can trigger that behavior to slow the robot down as it comes up to the object. And then once it gets to within that threshold of being a bumper, it then triggers the macro, backs up, and it's supposed to back up and turn slightly, and then basically save state before it does that. And then once the macro is finished, it sets the motor speed back to what it was at the moment the macro was triggered. And I have had that working. Unfortunately, demo mode broke things. So that's that. Number two is...
I think that counts as a silver star.
At least, yeah, that's good.
Yeah, the wheels turned, and yeah.
In response to sensors, behavior is toggled, you know.
Yeah. So this is the next thing. And this is the beginning of my Mars rover. I'm going to have a MR01 and MR02. And this is MR01, which is only a four-wheeler. But this is all Servo City Go Build stuff, so it's metric. I've got my battery underneath there, and that's a Makita power tool battery. Plugs in. I'm using the David Anderson style bumper, which is I've got a spring-loaded thing up here. You can see that. And that triggers the lever switch. And this whole front will be covered by polycarbonate. We've got our steering motors. These are the Go Build, what are they called? Rhino wheels. So they've got two choices with a bit of a softer rubber. So I've got the softer rubber, and they're on steering. And it's kind of coming together. I mean, this cost a lot of money to ship these parts here, but and it didn't turn out to be any cheaper to go through New Zealand Post. It was $1 cheaper, and I ended up paying $51 instead in New Zealand taxes. So I'm not sure I like that better. So that's all coming along, and I'm in the process of making little lever switch mounts and things like that. So I'm back to building hardware, which is where I like to be sometimes. It's nice to do software, but it's nice to do hardware as well. And then the third thing is a cooperative venture on the personal robotics chat board between myself, who's not doing very much at all right now, and John Gaultier. How do you say your last name, John? Gaultier?
I pronounce it Goche, phonetically.
Okay.
Gocha.
So John, myself, and there's a guy that I've brought in to the server from, I think he lives in upstate New York, and he's a university math professor named Alexander, and I won't say his name because we're recording, but his name is Alexander, and he is doing, I believe, the RP2040 design. John, I think, is doing most of the PC board design. I'm offering to do the artwork on the board so far. And but basically it's a motor controller, RP2040 based. It will have either a C++ code on it, or potentially a MicroPython one. We've got another guy named Adam who is looking into writing an I2C slave implementation for the RP2040. And if that's successful, we can move to MicroPython. And it'll be a motor controller board that will be open sourced. The Gerber files or whatever will be all available, and we'll publish all that online. And if that all works out, I will use that on my Mars rover rather than buying the more expensive Pyborg motor controllers. So that's kind of coming along. John's doing a lot of work with Alexander, and they're getting together. We've got a separate private channel so they can chat now. And in fact, I think we should have John go after me, and he can describe more of the details of what's going on with that. But that's all coming along, and I think that's it from New Zealand. John, do you want to describe the motor controller?
Well, sure. Basically, let me go ahead and see if I can bring up KiCad real quick, if you'll give me just.
Sorry, I didn't give you a warning.
Okay. Well, I've already got this loaded here. Okay, so now let me do a screen share.
Thanks, Marie. That's pretty cool. A lot of stuff this week, huh?
Yeah, busy. Lots of things going on.
Present entire screen and this screen. All right, and let's go to KiCad. All right, so I think what we've got now is we've basically completed all the circuit design, and just today I went through and took a swag at assigning footprints to all the parts. What we have is RP2040. This is based on the minimal hardware design that the Raspberry Pi organization posts, free for everyone. So that's the core of the design here. Then we have these two motor driver chips over here. It's going to be a dual driver board. It's going to take encoder feedback. And we're planning to basically support 12-volt power here. Let's see, what else can we say about this? We're going to have a chainable I2C interface here. We've got basically an in and an out, so you can have a higher level CPU talk to the Pi for control, and we'll be able to select up to 8 sub addresses on the I2C interface. We've also got some optional outputs in case we decide that some people would prefer not to have the Raspberry Pi 2040 do the encoder processing. We're routing the encoder signals off the board on these two connectors here if you choose to do so. And I have not yet. The next phase will be, selecting the parts, and this is actually the RP2040 original. This is the original design for the minimal design board. So I'm going to borrow kind of the core layout around the RP2040, and then going to add, basically subtract out all these unused GPIOs and add our additional hardware on this board. So is that about it? That about cover what you had in mind there, Murray?
Yeah, I think it's coming along really excellently. I'm impressed with what you guys have done so far. And I mean, I can't really claim, all I did is sort of say what I thought my requirements would be. So John and Alexander have done an excellent job of putting this together and starting the project. And the only downside for me is still this business of how I'm going to provide a 12-volt power supply, because mine is, of course, these 18-volt Makita batteries that are actually running around 20 to 21 volts. But I guess that's more up to me, because I've got to somehow get down to a 12-volt 5 amp per channel supply off of an 18-volt battery without too much loss.
Well, actually, in truth, you don't even have to come down to 12, because this part goes up to, I think, 28.
Oh, okay. So I can run the battery straight to it. That would be excellent.
Yeah, I can go up to 28.
Okay, then I don't have to do anything. This is perfect then. Yeah, and
anywhere from 2.5 to 28 volts.
Yeah, because one of the things that we had discussed was, I don't know how many of you are aware, but SparkFunds sell a series of what they call micromod, which is a series of processor boards for like about 6 or 7 different processors, like the ESP32, STM32. and RP2040, and then they sell carrier boards for that. And the idea I had originally would be to design this whole motor controller effectively using that framework, and then we could just plug and play with different processors. If you wanted to swap out an RP2040 and put an STM32, you could. But the difference in price, it's about $15 for the processor board and about $2 for the socket. And so you're adding like somewhere around $15, $16, $17 to the cost of the motor controller board, which is not a huge amount, but if you're doing 3 of these, it's a significant, it's like $45 US extra. And in the end, I think John beat me down on this one, and I've agreed that probably just going with an actual onboard RP2040. And like I said, we've got this guy Adam who's kind of agreed to have a go at writing an I2C slave implementation for the RP2040, because no one's done it yet, and we're not even sure it will work, but in theory it can. So if he's successful, I can, and I've offered to do this, I would write a MicroPython controller library for this board. Otherwise, we'll use the C one that Alexander is going to write. The only advantage of the MicroPython one is that I would get to use my existing PID controller and all the code that I've already written and put it, basically port that portion of the code onto this board and then have everything be in Python, both on the MCU and on the Pi. And that's always been kind of one of my goals, to see if we can write, that's really the goal. That's one of my requirements effectively, is to see how feasible a completely Python-based robot OS is. In the end, if that doesn't work and we can't get I2C running, or I can't port it or whatever, and we end up running it in C on an RP2040, that's all fine too. It's still a very viable design for a motor controller. And John, I think the overall cost is under $20 per board.
That's what we've been estimating so far. I mean, some of the parts are starting to add up when I start to look to see what's available. You've got a 50-cent part here, a 60-cent part there. But it'll still be under 20, I think.
Yeah, and that's a huge difference. This is a 5 amp per channel, 2-channel board for around $20. And if I want to buy the equivalent, which is what I was planning originally before the project came along, I was looking at the Pi Borgs, and they've got the Thunderborg, which I've been using, which is 35 pounds plus shipping to New Zealand, and then what they call the Pico Borg Reverse for some reason, which is a kind of a step down from that, which is again a 5 amp per channel, but that's like 33 pounds. So this is a lot. This is like half price. And we're going to open source the thing and have a little personal robotics logo on it, but basically open source the thing, and anybody can send these boards off to JCLP, whatever the heck, I can never,
JCLPCB?
ALC, yeah, I can never do it. Anyway, anybody could basically send the board design off to Taiwan and have them build a board for them. And it would be, it costs like $20. And that's pretty good. And if they want, they can modify because it's open source. So it's kind of all good all around. So it's a great project. I'm really happy.
Each of us is really kind of getting something from this. I mean, Murray doesn't have to feel very bad at this point for not contributing much, but because his contribution is coming on the back end when it comes to the software. So we're just at different phases here. And of course, I'm relying on them for tips on, they have a lot of, Murray and Alexander both have a lot of tips on the types of interfaces and parts that are available and selectable for the project. I don't actually have a use for this at this point. But I'm getting loads of experience doing this. And the next thing I really hope to get a lot of experience is I've never submitted anything for fully fabbed board. I've always done just the bare board and soldered it myself. So this is going to be a learning exercise for me to figure out how do you go to one of these manufacturers and meet their requirements for submitting board and getting everything to fit and so on. So this is fun for me.
Yeah. And I have to say one thing is that John has been chomping at the bit, as you guys probably all know, chomping at the bit to have some kind of a community project. And so we've got one now. So
I just wanted to see if it could be done,
It's hard to get us, herding cats kind of problem. We're all doing different things, and getting even 3 people to do the same thing is really hard. So,
and in these 3 people, how many miles are between the 3 people, right? There's no 2 in the same city, right?
Yeah, we're not in the same time zone at all. I think he's upstate New York, and you're Texas, John, and I'm in New Zealand. So it's sort of like, yeah, there's big differences in time zone, and our schedules are all like, I'm just whacked out time wise. I have almost no time, and the little bit of time I have to escape from everything else is robotics. So you get my time when I can pull other things apart, but it's a bit of a challenge to get stuff together. But the big advantage, of course, is that we do have the internet, and most of our communications so far has been asynchronous. So we have those advantages, and we can share parts. And I've got my Dropbox account open, so we can put the zip files together. And we're actually really taking advantage of the internet. So it's great.
It's phenomenal.
Murray,
So
I've
have you
thought that
thought about,
before in our communications because, because you're in the future from where we sit, that I think, oh my God, no, I've got to take care of so-and-so. Oh no, that's all right. I've still got 8 more hours. It's just in the past for Murray.
I love the fact that I live in your future. It just
You live in our.
Have you guys thought about like the RoboClaws? They have like motion profiles. You can have an acceleration to a velocity to, you can even do like to a position and then deceleration, to slow down and stop
Ray,
at that
I
position,
can't
or-
speak to what Alexander's going to do, but and one of the things I always like about having a chat with David is he always has a very different take on things, and he talks about things like performance and stuff like that, and on a PID controller. And to me, I totally agree that one of the things I've found is that I've got a YAML configuration file for my robot OS, and if I tweak the config for the PID controller or the slew limiter or whatever, it just changes how the behavior of the robot, how the robot acts. It's like right now the robot is really sluggish. It takes a long time to respond, and it kind of does this really smooth motion, and it might respond a little bit. But if I wanted to, I could tweak those down, like you said, a motion profile, and make it really jerky. And so that's all in my code right now. So if we end up implementing Alexander's code in C, I can't control that. And I'm hoping that we can get the I2C slave on the RP2040 running, and then I can port my code over to it. And if that's the case, then yes, then the YAML configuration would be ported as well, and we'd be able to set motion profiles for the way that the board and the PID controller and the slew limiter all act. And that's one of my goals. And one of the things that, one of the downsides of going with the soldered on RP2040 versus the micromod is that part of why I wanted to use the micromod, even though it would have been more expensive, is I could swap out to an STM32 board. And there is a demonstrable STM32 I2C slave in MicroPython out there. It's part of the actual MicroPython code base. As soon as we go over to the RP2040, we don't really know. And like I said, this guy Adam is going to try it, but no one has yet, maybe because the board's still new or the chip is still new, I don't know, but no one has yet anywhere that I've been able to find implemented I2C slave in MicroPython on the RP2040. So we would be a first. And if that works, then I can port my code. Otherwise, I'm stuck with whatever the effective default motion profile of Alexander's code is. Or, I mean, it'll be open source. I could break down and code in C, but that would mean rewriting a huge portion of my OS, which is all tailored, it's all functional now.
And there's always a possibility. I mean, the board design is basically considers 2 halves, right? There's your minimal design for your RP2040, then there's your motor driver design on one side. It may just come down to we create a second variant of the board with an STM32 on it.
Yeah, but the problem with that is you can't buy STM32 chips anywhere. They're just not available.
Well, that's what drove us toward the RP2040 to begin with. So
certainly,
but maybe that'll change in a few months.
And the alternative board wouldn't be an STM32. It would be to replace the entire thumbprint of the RP2040 with a M2 socket. And then you can just plug one of these processor boards, the micromod processors in, and we could default to the RP2040 initially. And then if anybody wanted to, they could swap that out and put in a SAMD51, a ESP32, anything they wanted, any of those micromod processors. And I would just go out and buy, and I've actually ordered finally, I've ordered a SparkFun two carrier boards and one of the STM32s, because I don't actually have an STM32 anywhere in the house. And so I'll have one of the SparkFun ones and also the Zio or Zio Pi board finally, after almost a month, has shipped from Hong Kong. So I will, or yeah, Hong Kong. So I'll finally have an actual little purple Pi board and the SparkFun STM32. So I can try this out and try porting over and see. And like I said, if we were to do a second version of this motor controller, I would just say put an M2 socket on it, and that would just be the second board design.
Yeah,
And then
and there's
anybody
no
can
reason,
swap any-
and there's no reason we have to do this in serial either. I mean, once we get basically, most of the design done for the RP2040 board, I can go and start the modifications for M2, M.2 connection.
Yeah, because the spec for that M.2 socket is on the SparkFun site, so it's just literally getting rid of the thumbprint and replacing it with the thumbprint for the M.2 socket and putting a little screw hole to hold the thing in place. So it's relatively simple, relatively.
So John, you've looked for STM parts. You can't even get them like through local distributors or something, or
Nobody has them.
really? Wow.
No, even the MicroPython store that sells the Pi board, nobody has Pi boards, and no one has actual STM32 chips anymore. They're just not available as far as I know. Although you can, yes, I know you can get whole boards, David, but you can't get the chip. And the fact of the matter is you can get the little micromod STM32 boards from SparkFun. So they must have a stock, obviously, but getting the chips seems to be just about impossible.
Well, guys, Murray, John, looking like good progress. Moving right along.
Yeah, thank you, John and Alexander. It's really coming along.
Yeah.
And I guess I can since is there nobody else in line? I can segue to something
well,
else.
why don't you continue on? And David, and at some point we've got Kumar in queue with a question, and Doug. So we've got. How about we just do like that? John, David, Kumar, and Doug. How's that?
Oh, okay. Well, yeah. Let me just take a minute here. I'll go ahead. This is really not anything you haven't seen before. I'm still preparing my Halloween spider. It's coming down to the wire, literally, because the last thing I'm gonna have to do is build some new wire harnesses for the new design. But I'm just to show, I'm testing the last leg that I'm about to attach to the spider right now. And I've written this little, I'm basically controlling it through Raspberry Pi. And I've got the leg there sitting on the bench. And what I'm doing here is testing the leg out by telling it to calibrate the motor position to the limit switches to find the range of motion of the limit switches. So you can see, and in this little program here, I can also, since I've got the current feedback, I can measure my current as well to see if there's any place where it's getting snagged. There it did the outer leg. The outer segment. Now it's looking for the limits on the middle segment. You can see where it's triggering and where it's hitting the limit switch.
You just got to watch out for smacking yourself in the head with the arm.
Finally, it's doing the hip motor, or the hip joint, if you will. And that's it. I don't know if you could see it running in the background there.
Really want to see it tap you on the shoulder.
What? Oh.
Yeah.
That's all I had.
That's looking good. We heard it. Does the hearing sound for some kind of star? Because we heard it moving in the background.
Well, I can't wait to hear all four legs running at the same time. It's going to sound weird.
Yeah.
I saw it running in the background.
And gold stars. There we go. That's motion.
Okay, I yield the floor.
Nicely done. Thank you. Okay. Mr. David, what have you got this week?
Very little, but I wanted to start out by saying when I came to work at the beginning of this week, somebody had put a gold star on my door. Was it any of you guys? Did any of y'all sneak up to SMU? Pat did it.
Pat.
I have no idea why it's there, but I took it as a positive sign. I haven't actually done anything this week, but I've been reading a whole lot. And it's led me down some interesting paths, which I would like to share with you all. And I'd like to start this by doing, I've done a number of talks, both on robotics and on art, where I've used the same example to get started. And I'd like to use that now with y'all. I know some of you have heard it, but it goes as follows. You're going to generate a mental image based on what I say. And so you're down at the coast, you're looking out at the ocean, a boat comes along and sails past you and disappears off to a spot on the horizon. So that's all I'm going to give you. So then, and this is interesting because I found that the younger audiences are both more creative with their answers and also less inhibited. So then that's followed by a series of questions. In your mental image, what color was the boat?
Brown.
Brown? Was it a sailboat or a motorboat?
White sailboat.
A white sailboat. Yeah. It
How many sails did it have?
was a sloop.
Sloop.
So 2.
Were there any people on board?
Nope.
I could only see one at the till.
Where are you standing?
I'm on a beach.
You're on the beach itself? You're not on,
I'm on the sand. Yeah.
You're on the sand itself. Okay, well, you know, we go on like this. The kids all get real excited and talk about their boat and their image. But the point it being made is that your brain, based on just a few acoustic signals that I sent into your ears, created this very detailed, complex image. And not just image, but a complete gestalt environment, rich with detail, none of which I gave you. And that in point of fact, that was not hard. It's not like doing math or memorizing poetry. Your brain just did it for you and handed you the result. It's almost like it's happening in hardware. And so I would make points about this. One of the points I would make is that your brain is doing that same thing right now. That is, you're generating a complex, highly detailed reality based on fragmentary information. And it does it all the time. And you're continually updating that model with your senses. But the model is much more complex and more complete than what it is you're sensing. And this has ramifications in when we start talking about perception and what perception means and so forth. Well, this past week, in a serendipitous way, I ran across the work of a couple of neuroscientists. And let me see if I can put them their names in the chat. You can Google them yourself. One of them her name is Robin Carhart-Harris. And the other, and there's some interesting interviews with our Donald Hoffman. Now, how do I put that in the chat?
Lower right corner, thought cloud bubble thing.
There we go. Okay. Don Old.
And of course, David, there's a whole subfield of philosophy and epistemology that deals with.
Don't get me started.
Okay, I won't.
Let's see, Robin Carhart-Harris. Yes, I got that correct. All right, there's a couple of interesting interviews with him that you can find on the net. But basically, these guys are neuroscientists and they're studying vision. And what they have found is that if you look at the, at the cortex where vision happens, that most of the signals that are going into there are actually coming from your brain, not from your optic nerve. That only about 10% of what you see, quote unquote, actually comes from your optic nerve. And Hoffman argues that you don't see things from the bottom up. That is, you don't start with an image and recognize things within it, but rather you view things from the top down. You start with a complex and complete model of the world, and then you modify and update that model with the visual sensor. So that the way, as I say, even right now, what you think you're seeing is actually a model that your brain is producing, and that what is coming in from the visual, from your retinas, even though there is some hardware processing done in the retina itself, the optical nerve is a small percentage of the signal of what you think you're seeing. And I think this has some interesting ramifications for artificial intelligence. In particular, if you think about the way we're currently doing it with neural nets, it's what he would describe as bottom up. That is, you start with the visual image, and then you try to say, okay, this is a car, this is a house, this is a dog, and maybe even this is a dog moving. But in point of fact, that the way we do it is the opposite of that. And I shouldn't use the word image because they're not pictures. They're much more. It's a much richer data set than just visual. And it understands, for example, Newton's laws. You understand how things move. You can make predictions into the future about where that ball is going to land based on its trajectory and so forth. So it all appears to be running in hardware. That is to say, it doesn't require thinking. Your brain just does it for you. So this suggests that, and I'm loath to say this, but it suggests that the model should be started from the other end. That is, you start with a complex model of what you think you're looking at, and then the camera and the analysis refines and corrects that. When I do this talk, I have three different examples that I give. The first one is something probably everybody's experienced, which is I'm driving down the street and I look in my rear view mirror and there's a cop behind me. So I immediately look down to see what my speed limit is. But I actually looked in the rear view mirror and I saw a police car. I saw the lights, I saw the markings, I saw a police car. Now when I look and begin to gather more information with my visual sensors, I realize that it's just a black SUV with a luggage rack, at which point I see a black SUV with a luggage rack. But it's not that previously I had a poor image. Previously I had just as sharp an image, but it was wrong. It was of a police car. The second one was a few years ago, I was driving down a country road and this jackrabbit jumped out of the ditch and ran across in front of my car. Everything about it said jackrabbit, the size, the shape, the color, the way it moved. But as my eyes locked onto it and I began to track it, I recognized it as a brown plastic bag blowing across the road. Within the first few milliseconds of looking at it, the movement was wrong for a jackrabbit and forced me to re-recognize it. But what I first saw was a jackrabbit. It wasn't that I saw something like a jackrabbit. My brain produced a jackrabbit. And the third one is my favorite one. Driving along the highway, this is some years ago, on a hot, blistering Texas day with no air conditioning in the car. And I glance across the highway and just as my eyes glance past, there's a sign that says ice cold beer. And I'm thinking, what? How can there be an ice cold beer sign on the highway? And it's a highway sign. So I look back to find it and I gather more information. And it says, bridge may ice in cold weather. But that's not what my brain wanted to see.
I think that explains beer goggles, doesn't it? You know, like late at
Well,
night.
I'm just kind of fascinated by this, and it suggests, as I say, our current approach to doing this in artificial intelligence is we build these big neural nets, and I'm going to give you 10,000 pictures of what I think is a fire hydrant and 10,000 pictures of what I think is not a fire hydrant, and then you're going to come up in your own magical way with something that I cannot understand. When I will show you a picture, tell me whether or not this is a fire hydrant. And the suggestion from the neural research is that we're going about this backwards, that we need to start with the models and then refine those models with the visual and sensory input, rather than trying to start with the input and build the models. Okay, and I'll open the floor to discussion, but I see Kareem shaking his head, so this looks good. But I have one other thing I'd like to stick in here first, which is a great post on the Seattle Robotics list last week, and let me see if I can grab it and put it in the chat. Basically, let's see. I don't know if you guys follow the Seattle Robotics list, but basically these guys have determined that real neurons, like the ones in our brains, have a mode that was observed and nobody knew what it was, which is that they send little bursts of pulses. And it turns out there are special sensors that look just for those bursts, separate and distinct from the information. So it's sort of out of band signaling. And those bursts have to do with basically efficient routing in the network. They improve the routing of the network. So there's something else going on in those neurons. And these papers go into it in detail. And she did a real good summary of them in the post. So when you get a chance, you might want to look at that. And that's all I have.
Wonder if I should let Kareem go first, or the only thing my first reaction, David, is that I don't disagree with what you're saying, except that like my academic background, and I've been on, I guess, 4 or 5 different working groups for computer-based ontologies, and even thought about taking a job at Psycor in Texas, in Austin, and the whole psych ontology project, if any of you are aware of that. And the top-down approach, to almost a great degree, has been an utter failure in terms of providing anything really valuable. There's been millions and millions of dollars and lots of projects out there creating these top-down ontologies and designs, models of the universe kind of thing. And they're all really interesting. And in the end, I've always characterized them as really big, expensive toys because they're not rooted. And most of the both informed arguments against them in the computer-based ontology world, as well as in the analytic philosophy world, is that these models are not rooted. They're basically just abstract creations that don't take into account language and context, and there's all sorts of errors. And so, yes, if from a top down, if they could solve all those problems, we'd have the ability to model a world in such a way that we could have kind of a push down from the top to meet the stuff coming up from the bottom, and maybe we'd find some compromise where we could actually build that connection. But frankly, I haven't seen anything, and I've not been digging as much as I was 10 years ago. But my understanding of the top-down approach is that it just misses. There's like, of all the different researchers that I spent years digging into, almost none of them, 1 out of hundreds that I can think of, maybe 2, have a background in epistemology. So they're just computer programmers like I was, just playing around, and they don't really understand that the fundamental problem is that absolute distinction of language and reality. And the whole thing with Rodney Brooks that really caught my eye was that Rodney talks about embodiment and all those things he talks about as an alternative to the top-down approach. So the bottom-up bit, go ahead, David.
My only response to that would be that all those things you're describing are very theoretical, even philosophical. And what I'm describing is work that has been done in neurology in the last 4 or 5 years. I'm not talking about a philosophical approach that's generic to top down. I'm talking about specifically how we see. And go look at some of the interviews, especially the Donald Hoffman interview. He does, of course, a much better job of explaining this than I do.
So you're saying that a top-down approach wouldn't be like a computer-based ontology thing at all. It would be a practical, embodied, rooted.
I'm saying that the reason that approach has made it into the news is because it appears to be the way that our vision processing works. And if that's true, it suggests that the current approach that we're using to visual recognition in artificial intelligence and robotics will never be able to accomplish what we accomplish because it's not doing it the same way. Kareem?
There's just too much juice there.
Yeah, sure. Fire it away, man.
And I'm not going to claim that I have any of this worked out, but I've been tracking all of that same kind of stuff for years. So first of all, congratulations, David. You just undermined behavior-based robotics.
Exactly that. That's why I started by saying I hate to say this. Did you not notice that? I said I hate to admit that.
Yeah. And then I would also say that it's, the language is pretty crummy around this kind of stuff. I wouldn't even call it top down. You might call it inside out a little bit. But I would point out that if you when you describe an adult visual system and how processing occurs, that sort of ignores how we got there. So when you take a developmental approach and you start thinking about how when an infant opens their eyes for the first time, there isn't a whole lot that's pre-programmed there in their visual systems, right? And you can sort of prove that. So I've had some friends who were like neural researchers studying the optical pathways of cats, for example, and so you could do things experimentally that you can't do on humans, and you could show that if you if you kept cats' eyes closed, kept them in the dark longer than they normally would be, if they hadn't received certain kinds of inputs at a certain stage in their development, they wouldn't be able to see certain things at all. And so there is a continuous cyclic process that's going on. And yes, there are models that are being built up inside our brains. And once you're an adult, or once you have a developed system and you're recognizing things, it is an interaction between those levels of abstraction. I'm not going to quite say meaning, um, but you have these different kinds of models in your head, and there is a battle for supremacy over which model matches what you're currently taking in, right? And the whole attentive system is like a whole other mess. A lot of this is happening below the level of our awareness, and then how you interpret it and associate meaning with what you're seeing, to deconstruct the scene that you're building in your head. That's a whole other level of complexity. And the only thing, so first of all, it's fascinating stuff. I love it. I think we're still very, very primitive in our understanding of how the human visual system works. And I would completely argue against the idea that that we have to recreate the human visual system for it to be considered AI. The whole definition of AI has changed completely since like the days when Murray, you're normally talking about it, when you're thinking classic AI, right?
Yeah.
That was when I got discouraged from AI as well. But the way it's become now, and most people don't really call it AI. It's more machine learning from inside the industry. And AI is more of a marketing term than anything else. I'd say that there's a lot of interesting things happening in machine learning, and I don't know what my personal interest is not necessarily to see a walking, talking alternate entity that is considered sentient. I think it might actually happen, right? And maybe it doesn't have to be talking or walking, but there's going to be sentient things probably that are not bio-based at some point. But now we're getting into the real, distant realms. But I think that there's a lot to. I would also say that when you think about how you train a neural net to recognize, say, a very specific set of images, that what exactly you're doing is you're creating a mental model in the configuration of the trained network. That's exactly what that is, right? So that information is embedded in there. It's not going to be universal, but there is something in there that equates to a model. Nobody can describe really effectively what that is. You can't take the individual parts out and say, I know for sure that that is doing edge recognition on a particular kind of facial feature or something like that. But it's just magic. It works.
You guys may remember when we were doing the donkey car experiments a couple of years ago, and somebody had showed it running around in their garage, and I believe it was Ray who said, well, how do you know it's actually looking at that tape on the floor? How do you know it's not just looking at the walls of the ceiling? So he had him pull the tape off the floor, and sure enough, it could still drive the route. It wasn't looking at the tape. So I don't disagree with that, but I made some notes here while you were speaking, if I can respond.
Go ahead.
I actually had a couple of infants to study for a few years, and I'm not convinced that what they initially see is anything more than a flood of colors that they don't make into shapes or anything.
Right.
Those of you from the 60s who took LSD may know what I'm talking about. I don't think they actually I think they have to learn. For example, one of the studies I read talked about how they learn as their mother approaches them and moves away, that is not a head getting bigger, which is what you see on your two-dimensional screen. It is actually a head staying the same size, moving in and out. So those are all learned things. However, having said that, the question I would ask is, all right, if it is the case, as these neural scientists suggest, that most of the signal in your visual cortex is coming from your brain, not from your eyes, would that be the same for, say, a honeybee? Does their vision work the same way? Are they working on an internal model which they are updating? I'd like to know that. I think that would be really useful. And then finally, I would really, I can't defend these ideas because I don't understand them very well, but I really would encourage you all, go look up the Donald Hoffman. There's a couple of good long interviews with him. And there's one where he says something like, we don't see reality or something, guaranteed to get headlines, where he's able to describe their work and how they've arrived at their conclusions. And as I say, this is not from 10 years ago or even 5 years ago. This is all fairly current stuff. I actually ran into it because there's a painter, a visual artist, who is quite fascinated. And I can see the parallels. I had a very good friend who's an illustrator, and Wiley Akins. And one of the things I would watch Wiley do is he would draw a tree. And then he would maybe just put in a couple of lines that suggested bark. And I would see bark on that whole tree. Somehow he is able to tap in, as an artist, to tap into that low level. And as I say, he's also a good cartoonist. So he can draw a picture of your face with just 2 or 3 lines. And anybody that knows you will say, that's Kareem. What is he abstracting there? I think maybe all visual artists, either by training or by temperament, are able to tap into that level where just a line drawing is enough to suggest a complex reality. So anyway, as I said, I was very interested in this, and I really recommend you guys go search. I wish I had a link. I couldn't find it, but go search on Donald Hoffman and look at some of his videos.
I just put one in for you, David. It's a TED interview with him on his theory and how he experienced reality.
That sounds good. Yeah, that sounds good.
Yeah.
David, the one thing I remember about reading about early childhood development with regards to brain development was that there was this notion that babies, when in the first few weeks, first few months of their life, can't really focus. They, like you said, they see shapes and things like that. They don't have a very, as far as was known, they didn't have a very fine focus on detail. And what you're saying today suggests that it's not so much that they couldn't, obviously their eyes could be unable to focus, but it could also be that they're actually learning detail about reality enough that they could focus. In other words, they're creating the model that the 20% that they're getting in terms of visual information, they don't have the 80% in their brain yet to provide the world model that gives them the detail. And so they're gradually very rapidly, actually, in the first few months of their life, creating the world model that allows their eyes to focus. No, not their eyes, their visual system to focus. And
also, I think that they are learning how to operate the hardware. I remember watching my boys discover their hands. Any of you that have been around babies, it's a marvelous thing, because up to that point in their life, it's just this pink thing that flashed through the field of view every once in a while. And suddenly they realize that they can control it. And there's this look of astonishment. It's like, they're so pleased.
Lasts a couple of weeks, yeah.
Yeah.
And then they train their parents by dropping stuff on the floor and realize they can control reality. They can actually get their parent to pick up the thing they dropped off the table.
Well, there is some hardware processing that goes on in the eye and in the optic nerve itself. For example, signals that move horizontally create higher amplitudes than ones that move vertically. And there's some other things like that. But my suspicion is that for a newborn, it's just a flood of pixels. They don't know objects. They don't know foreground, background. They don't know any of those things. It's just a flood of colored pixels. And this amazing brain starts to extract information from that.
But your insight about the honeybee thing is really an intriguing idea because, of course, honeybees don't live that long, and they have much more complex hardware. Their eyes are enormously more complex than ours. They've got, you know, the what are they,
Compound eye.
faceted eyes, but they don't live very long, so they don't have a lot of time to build world models. So maybe they're more hardware based than software based, effectively.
And if that's possible, maybe we are too.
Certainly, it's an interesting idea, though. Certainly.
As
I
I
found it
said,
interesting that you talked about it being difficult, about thinking versus having something automatic, and it's all happening in the same set of networks, right? Well, I mean, there's different levels to the networks in our heads, but you know that it's interesting to figure out what are those things that feel like they take work to think about as opposed to which are easy and automatic. And often people talk about when it's automatic, it's just something that's already fitting very well. It's something you've learned so well, right? Just like, you know, an athlete who has perfected a certain movement or something.
Muscle memory.
The quote muscle memory. It's all actually wetware, and updated. You know, when you, I think most people here would know that as you learn, as you update your neural networks, you are actually changing the physical interconnections in your head, right? And so that is that point where, and in the younger people, those connections haven't been wired quite as hard, and so not only are they able to sort of escape sort of more rigid thinking of us older folks, but they also aren't going to come to conclusions as efficiently, right? And it's more of a struggle to learn things that for us are automatic. So
I agree with that, Kareem. I would just add, in a related form, that my experience as a musician and other musicians, I think, at least perform professionally, will tell you the same thing, which is that what you do in the studio is slow and methodical. That what we think of as conscious thinking is actually its advantage is that it's powerful, but its disadvantages is that it's slow. It's kind of like in computers, hardware versus software. So software is flexible and powerful, but it's slow compared to hardware. And I would quote to you that great 20th century philosopher Yogi Berra, who said, and this is exactly on target, he said, "You can't think and bat." And I would tell you that musicians that I know will tell you the same thing. All of the conscious work on the music happens in the studio. When you get out on stage, you have to turn that part off. You have to tell your conscious, just enjoy the music. Don't try to control anything. You'll just fuck it up. You're not fast enough. You'll find yourself constantly behind, trying to catch up to the music. So you have to go out there and just shut off that part of your brain while you're playing. And I think that's what Yogi Berra was saying. You can't think and bat. Thinking is too slow.
Yeah.
But I don't disagree that basically we're using software to build hardware algorithms, which are then super fast.
It always freaks me out with jazz musicians in particular, because it doesn't seem to me that I don't understand it well enough. You know, I'm not a musician, not properly, and there's something that I don't get about the complexity of jazz, that how you can turn off and yet truly have I don't know how to describe it. It's just
I know exactly what you're talking about, Kareem.
Yeah.
My forte is improvisation. I've done that. I did that for many, many years. I did it in Carnegie Hall. I've made lots of recordings and stuff. And it is complicated because part of your consciousness has to be there. So forth. But it's also true, even in that circumstance, that if you think too hard about it, you can't do it.
Yeah, and it's David. I think I might be a miniature version of David, actually. I'm not sure, because it turns out we have a huge amount in common, because I'm also a musician, although I wouldn't call myself accomplished. But all of the music I've produced for the last 5 or 6 years has been improvisational as well. And every time my best mate comes over and we record or we play, because we played live a bit too, but it's really just the recording process, even because it's improvisation, is that as soon as you start thinking, you just screw the whole, you're not going to get anything out of that evening's recording. You have to somehow, and we've used alcohol, but somehow you've got to let go. And if you're tied into your physical body and you're thinking about what you're going to play, it's like Yogi Berra, you just can't play at all. It just sucks.
And there are ancient traditions of this in other parts of the world that go back much further than jazz. In a lot of the world, all music is improvised, always. And the whole idea of writing down the same piece, to a tabla player or a sitar player, telling him that he's going to do exactly the same piece that he did yesterday, he'd be offended.
And that's actually one of my original inspirations. It was actually Indian music, because of course, some of the greatest improvisational music in the world is Indian music.
So as I said, I had nothing to offer about robots, but a few rabbit holes to lead us down, and that's my contribution for the evening.
Actually, I think your insight about honeybees is an interesting one, because it gets us back to kind of the territory of behavior-based robots, which is try to figure out, away from the human brain and the complexity of that, if you simplify it down far enough that we could maybe implement something in C or Python, what can we pull out of that? And that's, the machine learning side of it is one thing, but even on the low end that I'm running at, is there something we can pull from that?
I would say, and basically in response to what Kareem observed earlier, which is that you can understand why someone who was drawn to improvisation would also be drawn to behavior-based robotics.
See, and this explains a lot for me now, because just looking at my robots growing up, I understand now that they're just very good improvisational robots.
And we've already seen David's robot do the honeybee wiggle on its dance, right?
It's just they just have to improvise some more. That's all. They're thinking about it too much. They're overthinking things.
Hey Dave, did you happen to see there was a special on KERA last night, and I think it was called the Bees in My Garden, and this guy during the COVID lockdown in the UK basically just decided to study and film the bees, different types of bees in his garden, and he more or less followed one, a lot more than the other bees in his garden, and he felt that the bee recognized him. So, and that, he had heard of other studies where they thought that bees could actually recognize individual people.
Oh, have you heard crows? Crows can recognize people's faces, and they've decided in them now that they hold grudges.
Oh, yeah.
Ray, what was the name of the special?
I thought it was The Bees in My Garden, and it was on KERA last night.
Yesterday, we went down to the beach and got fish and chips, and a seagull pooped on me, and I'm going to keep my eye for that seagull, just like,
You're going to hold the grudge.
I know what he looks like. He knows what I look like.
I do have I have a book about bee behavior that my mother gave me. She's a botanist and is fascinated by these things. And one of the things I learned is that, okay, the wiggle dance that John was referring to, when the bees go out and find a good source of nectar, when they fly back with it, they do this little dance to tell the other bees. Right. And there's several pieces of that dance. If they have a horizontal surface to dance on, then the angle that they dance along is the angle to the sun that you need to fly in order to get to the honey. The length of the dance, how long they wiggle back and forth, is how far away it is. And then other bees can come and taste the honey, a little sample of the nectar you brought back, so they can make an individual decision, that's not good enough for that long a flight, or I'm too worn out for that long a flight. But the fascinating part was, if there's no horizontal surface to dance on, then they dance on a vertical surface where straight up represents the direction to the sun. So they are doing a 3D transform. And the other bees watching them know, that the angle off from straight up is supposed to represent the angle horizontal to the sun. And I just find that amazing, I'm sure, like with ours, I was saying earlier that we automatically understand Newton's laws because we know how things move. And I believe that's probably in hardware. And it may be for the bees, it is also. Bees are cool. If we could get our robots up to the level of a bee, we could rule the world.
Oh man.
Does that work for northern hemisphere and southern hemisphere bees?
I think that the sun is the same.
All the bees down here in New Zealand just starve to death. They don't live here anymore. They can't make it.
I
Leave
thought
the nest and you go the wrong way.
I thought they just all fell off. Isn't that they're on the
Yeah.
other side?
Cool.
Thank you, David. That was cool.
All right.
Nice
There's no
rabbit
knowing
hole.
where this will lead us, but it's just going to be food for thought. And there's at least a few good videos and papers to watch and read here. So, all right. Well, next in line, we have on the maybe discussion phase, I think Kumar been very patiently waiting to raise a question. And then after Kumar, we have Doug P. And then we have no one in queue after that. So, Kumar, what you got?
I've been reflecting on this esoteric conversation, which I will ring through my ears and I'll be trying to figure out and learn more about it. And I'm thinking I'm going to talk about something absolutely mundane. And so I'm going to get people out from there down here. But really speaking, it was more of a question to get opinions from people more than anything else. I started on STM32 when I got my first Nucleo board last Friday. And it was mainly at the instance of Murray talking in the personal robotics group about the STM32, how everybody in DPRG uses STM32. So now when I got it, obviously there's a first learning curve. You see a blinky LED, etc. And then the questions which are going through my mind are really a few questions. Question number one, I heard people have built robots with only 2% of the CPU of the STM32 utilized. That means you don't necessarily need all the horsepower of that to do it. It's powerful enough that you don't need everything to do it. The second thing is that my particular Nucleo board, for example, has a flash. It's the 64 Nucleo, not the 144 or the 32, but it doesn't have any card. And then we say, when you want to go to Python, whether it is Circuit Python or C Python or MicroPython, Python has got more code. So I'm using 2% of CPU. I can do marvelous things. And then when I want to make it simpler, because I want to write in Python, it's going to occupy memory. Then the question comes is, MicroPython is open. Everybody can do it. It's got more control over things. You can handle interrupts, pass things to different cores. So, okay, MicroPython is the way I want to go. But I'm not in a position where I want to dig deep, understand the details of MicroPython, interrupt processing. I just want to get a robot up and running. And when, for example, Chris was showing his robot with the LiDAR, I say, how soon? Can I get it in 1 week, a LiDAR running on top of that, STM32 to work? I know you don't believe that to be the case, but when I got my RP LiDAR and I connected with the Raspberry Pi, it took me maybe about a week to figure it out. And I struggled till 2 a.m. in the night and did some bunch of stuff and figured it out. So the question I want to bring over here is, I'm a noob. I don't know STM32. I just started last Friday. At the same time, I have a vision of building a robot with the STM32. I do want to get PIDs and encoders and LiDARs and all over there. So what should I be thinking about? And one other input which I have is, Adafruit is very good in terms of support, but they support CircuitPython. And therefore, if I buy a board from Adafruit, which is CircuitPython based, I can get things done quickly. Because when I was struggling to get my OLED I2C work, I went into the Adafruit channel and I typed in something. He said, go change this instruction and make the IP address equal to 0x3D. And in 1 minute, it got working. And Jim, who is of the DPRG group, also has done a whole bunch of work on OLEDs and I2C and STM32. And he was gracious enough to take a call during Sunday and talk to me for 5 minutes to figure out and get all the help he did, but he could not figure it out. So the question to the team is, I'm not an expert. I would like to quickly make something, and not wonder and get into the details of how do I design a board which will take me so long. I'm not that guy. So any guidance for me or any inputs for me? And that's really what I meant, Carl, that I have a question. I don't have anything to show. And I'm looking at this group of people who have been working with STM32s for a long while and say, tell me something which will get me make things faster than slower.
What's your question? I know that you said it numerous times, but the real question is, why are you building the robot in the first place? I love the fact that you want to just get something going, but why do you want to get something going? Is this about your own education? It's about your developing your own capabilities to understand robots and systems and things like that? Or is that what it's about?
Yeah, it is about that. And just the fun of getting a blinky LED, and I made the LED run, or if I got the LiDAR. So many people ask me, what is it that you're trying to accomplish? What is the goal of your robot? I don't have a goal of robot. I just want to understand these various functions and learn so I can later on figure out how I can connect them together.
But then you're asking for advice about platform decisions, right? Um, and where I guess you're also asking for how do you get a productive experience as fast as possible, or is it about how do you get to um, learn all of the ins and outs? It seems to me like you want to develop practical experience very quickly. Is that correct? So don't worry about just sometimes we agonize. So I spent years when I was first starting out agonizing about, is this the right board to use? It doesn't matter. Just get something started, get something done, start building, choose a platform. You'll end up finding that you may have to switch. You'll switch multiple platforms over the years. But if you're a true hobbyist and you're trying to figure something out, I would just say get something started and just keep building on it, and switch when you find out you've reached the limits of it. You can't expect to make the right choice because there isn't a perfect fit for everyone.
But the key is, though, you do need to have a baseline to work from, and there are certain boards that do require more of a learning curve. So that's why partially the treasure would be is what are your end goal and how fast do you want to get to that end goal? Because Raspberry is much more intensive than an Arduino, for example. And then from there, Ross is even more advanced parts to it, at least in 2 or 3 years back. When I looked at Ross, it involved even another learning curve. And the key is some of this stuff has good documentation, some of it doesn't. And it's hard to sometimes find even to know if that's good documentation. So, yeah, you're right. And there's a learning curve. And I agree with his statement a little bit that, yeah, you have to have a baseline to start from.
Yeah, I'm hearing. I'm hearing the way you talk about it, Kumar. I'm hearing that it's not so much about the end goal because you don't really have one defined at the moment. And if you don't have an end goal in the long phrase or in long space sense or the short space, then without an end goal, you don't have the definition of done, right? You don't have a criteria to say good or bad. So what I'm hearing, though, and just to listen to the way you describe it, is that you want to get your hands dirty. You want to play with this. You want to play with that. You've got some concerns about, well, do I want to do this if it's efficient or not? Like it seems wasteful if it's only using 2% of the processor. And I think that this is where Kareem had it spot on. That don't worry about it, right? It seems like you want to get something up and running the next 2 weeks. Forget about the future. Set your goal in the next week and say, I don't care how good this is. I just want to turn this on, make it blink.
I agree with Maria a little bit, Carl. But the key is you can get so frustrated because there's not documentation and whatnot that you have to have a little bit of a base to work with.
Well, he's already got one.
He's got it. It's in his hands.
So which bar you were going for, you said? That you said? an arm, or what was the board you were going to use?
Yeah.
I have in the you guys have been at this for years. I've been doing this
Right.
maybe for 2 to 3 months. But in terms of the varied boards which I have played with, I played with the Raspberry Pi, I played with the Jetson, a Qt Pi. I just bought the STM32 last weekend. It arrived. I worked with an RP LiDAR. I played with ROS simulation. And I'm
Okay.
not saying I want to take this ROS simulation 1, 2, 3, 4, 5 and go to that place. I got an RP LiDAR running on ROS. I'm like,
Okay.
done.
Well,
What next?
the first goal is which board were you comfortable with and you think will give you the most bang for the buck? And then the question would be is there necessary documentation you need for it? It would be a way of attacking it effectively.
Sounds
So
to
I
me
do
like
agree that boards, there are certain benefits and drawbacks on boards, but if you're going for a base, any of the boards work. It's just a matter of which one do you have, which one is easy to get a hold of, and then from there, the necessary info documentation for it.
Kumar, I tend to agree with John and Kareem here that you're going to learn so much, and I don't mean to be flippant here, but there's a world that you don't know yet, and so just grab an environment that you feel comfortable with and go, and you will begin learning those things, and then maybe down the road you'll go, I think I would rather use this environment now that I have a better understanding of the problem space. But it's hard to make that determination until then. So just get whatever environment you're comfortable with and start, building things and writing code.
Well, and a lot of the people in this group are also into building autonomous robots, which is really a very complicated effort when you look at it. Maybe the thing maybe you don't want to build an autonomous robot. Maybe the thing you want to do is to start with something simpler, and use that as a jumping off point.
I'd like to build on John's. Everybody who's been here is probably, if you ask them to think about what happened when they started out and how did they go, you're working with ARM. That's fine. If you're comfortable with it, that's great. But when you want to go for your robot, don't try to make an autonomous navigating LiDAR robot to start with. I would say everybody in this group probably started off with a wanderer. And so what does a wanderer do? It just wanders.
Or a line follower.
And then the next one, is a line follower or a tabletop robot. So a tabletop robot is a wanderer that wanders all over the table but never falls off. Okay, because it has drop sensors. Very, very simple. You don't even have to have a robot that runs in a straight line. Okay, don't need PIDs. You don't need anything. All right. So the first thing to do, like I say, is try to start off at the bottom and get probably a wanderer. So, okay, well, what can make a wanderer interesting? There's probably 3 interesting wanderers. One of them is one that has a bumper or a sonar or something, and it just wanders and avoids things. Okay, so I'll call it an avoid wanderer. And then the second one is something is one that's either a cockroach or a moth. Okay, a moth is attracted to light. So what you do here is you're going to take two light sensors, and you're going to put one on each side of your robot, and you're going to have the robot turn towards the one that has the strongest light. Then go take it into another room that's in the dark and turn it on and let it roll. It'll eventually get into your lighted room and it'll circle your light. Really very satisfying. And also if you have kids, they go nuts over it because it looks like it's smart, even though it's not very smart. But again, you don't even need to have anything that runs in a straight line because you're only making one decision. Turn left, turn right. All right. So once you get to that level, I would say the line follower. All right. Now the line follower, the basic one, I wouldn't bother probably with a 2-sensor line follower. I'd probably move up to one that has multiple sensors because by this time you're feeling it. Hey, but you don't need a PID. You can. I mean, I remember one club member a long time ago literally took he had an 8 sensor line, and he took every possibility of those 8 sensors and assigned them a motor value. Okay. And he had a lot of fun and he worked really well and he planed it, got it sensed up. The next one is a line follower with a PID. All right. So now you're starting to learn how to control speed. Okay. Well, actually, there you're not controlling speed so much. You're controlling. Again, you don't have to even go in a straight line. All you're really controlling is where on the sensor you're reading, and you just keep building up each level. So the next one you might want is one that can do waypoints. Okay. Then the next one and then we'd have contests like go forward up, 30 feet and come back. So now you have to know how to do a straight line. And so, you pick your small victories and you work your way up on that. And you're building and you can, now here's the place where I would think that could get you a big help is if you can somehow build a framework so that when you add these features to it, you don't have to start at scratch again. Otherwise, you're just building and enhancing your software base. But that's how I would go about it. I mean, just like I say, set yourself a goal. I mean, make yourself a tabletop robot in 2 weeks. All right.
Thank you for all those perspectives.
Okay. And by the way, if you're going to use ARM, there's one thing you need to be aware of. They have a feature that you can run encoders off of one of their timers. There's a certain mode of their timers, so which makes it a lot simpler than some of the other sensors. And just keep that in the back of your mind when you get there.
And it uses no CPU cycles to do that.
Right. Yeah. So I'm just saying that's one thing the ST ARM timers have that's kind of cool.
I would add on to, I agree with what Doug said completely. I would add on to that in my early roboting days, when I was running around seeking on lights, I had a robot that could do, I still do, that could do what he described as moth and cockroach mode. And my experience is that moth mode is pretty cool because we tend to light the areas in which we wish to go. And so the robot will go to those areas. Cockroach mode, the damn thing crawls around behind and bangs around behind the couch. It's really not that useful. Telling it to go away from, maybe that's a useful behavior if you are a cockroach and you're trying to avoid being stomped on.
David, what are you telling me?
I'm just saying that in that particular case, attraction mode is more valuable than avoidance. But there are a whole lot of things that you'll learn just about how the robot moves, the kinematics of controlling it, that will be valuable for all the rest of the robots you ever build.
Yeah.
You're building a series of robots with your long-term goal of building a good roboticist.
And you don't.
In fact, one other experiment which I came across, which I have not yet tried. Go straight, take a right turn, go straight, take a right turn, and when you come back, come as close to the starting point as possible. And it may seem trivial, but it doesn't happen because they all curve and do things. So even if I can get that running as an example,
that's actually pretty advanced.
It's advanced, okay.
That's it's one of our challenges every spring.
Yeah. And here's the other thought: you don't necessarily have to try to solve the same problem that most of the people are solving here, which is an autonomous navigable robot. Is maybe like me, for example, I'm building this robotic spider as a Halloween project. maybe
Exactly.
a Christmas display that has some robotic elements to it. Any number of other things problems that you might want to solve creatively that that don't require a real complicated design to start with, and that maybe that you can build on.
Thank you, everybody.
More
Just
than you ever
listening
expected, eh?
Yeah.
gets the mind going, right? So I just wanted to
Well,
bring it up. Thank you.
by the way, your experiences with Python on STM really excited me. I think I'm going to try. You're a distraction, you know that. You know, I've been
I
trying.
am distracting.
Yeah, I've been trying hard to stay focused.
That's a platinum star, Kumar, to distract Doug. That's platinum
But
star.
you got me seriously distracted. I'm going to have to pull out one of my nuclear boards and put my MicroPython on it. I mean, I just got to do that because
Kumar, you have
that just
succeeded.
sounds cool.
Kumar, you
Yeah.
have succeeded where I have failed. I've been trying to distract Doug for a couple years now.
Yeah.
In fact, I learned something new when you were talking about Circuit Python and Nucleo. Almost everybody talks about the R something to go there. And in the personal robotics server, somebody said, don't do that, just use Thorny IDE. And when you use the Thorny IDE, it recognizes there is a Python board and it gives you a GUI kind of thing, like a directory structure where you can move things back and forth. And I'm like, it's so easy to do it. And once I got the hang of it, and I'll strongly encourage anybody here to the personal robotics server where Murray pulled me in from an Arduino group, which I joined about 3.5 months ago. I get up, I go to sleep, and I look at the personal robotics server. Because you send a question and people respond. And sometimes I won't talk too much about it, but when Murray responds, the conversation goes for like 50 responses back and forth and back and forth. I'm like, what are these guys talking about? But for me, the one thing which I got is when I ask a question. And that's the challenge I have with the DPRG. In fact, the reason I asked that question, do you have a Discord kind of server, is you have to send an email, somebody reads the email and responds back to it. But in the Discord server, you send a question and the people immediately, the people who know, they respond and you get a feedback and you're able to progress. And the idea of you are stuck and you don't have no idea what to do, and within about half an hour you are able to progress is the benefit of working in that environment. But this Thorny idea, I got it from the Discord server.
Yeah. Another one, now that you've got yourself a nice setup and you're happy, I'll tell you that PyCharm is really nice too. Okay. So that's PyCharm.
Kumar, sorry.
Go ahead.
The only thing I was going to say is that what you're describing, Kumar, is what I've kind of called a workflow. And as a software programmer, because that's what I do for a living, and I get thrown into a Windows environment or this or that. And what I find is that you need to get into a workflow. So you get a place where you can find a place to put your code and store it and save it and get into whatever editor you like to be in, whether it's an IDE or Vim or whatever. But getting to the point where you can program, make a change and get it to run on the robot, see what happens, and get into that flow, as well as being able to store your code. So for me, and this is sort of one of the reasons I'm on a Raspberry Pi and not on a microcontroller, is that my workflow involves being able to SSH onto a Pi. I do all my development on the Pi, and I store everything from the Pi onto GitHub. And that's been my workflow. And then with the microcontrollers, I'm using R shell now, so I can be on the Pi, use R shell to get onto the microcontroller, do programming in Vim on the microcontroller, and then rsync back all that code onto the Pi, and then GitHub it up, push it up to GitHub. So my point though, without getting into too much detail, is that's my workflow. And I've developed that, and I'll have to get a different workflow if I'm on a different computer system. But as a programmer, I try to find myself in a workflow that's comfortable for me, is fast, gets me quick turnaround, like Thorny for you. Any of these, like I'm on Eclipse all the time, which is incredibly complicated, but I have a workflow there. And so getting into the place where you can kind of quickly turn around a change in code and see what happens is really important, because there's a certain threshold where if it's too slow, it's slower than the way your brain operates and you can't function at all. It's like it slows you down so far that you can't quite get into the ability to play chords. You're just playing single notes. And so you found Thonny, but what you'll want to do on any one of these computers you work on is develop this idea of a workflow so you can get quick turnaround and see results quickly.
Thank you.
Kumar, I also have a prejudice I'll throw in here, which is that, and this is kind of what John was saying, you don't necessarily have to have your goals set by the contests of a particular robot club. As a matter of fact, you're probably better off not to. And if you look at like what Chris has been doing, he's not trying to solve any particular, he's trying to, if I may speak to you for you, Chris, to create a sophisticated robot able to do sophisticated things, at which point he will find that all those robot contests are trivial. So that's just my own personal prejudice. I know a lot of people, they design their robots around whatever contest that the particular club, and they don't build robots if there's no contest. I would advise against that. You know, go off in your own direction. Hell, we'll come up with a new contest, you know, if you can do things that nobody else can do. You know?
Thank you so much, guys.
And then that just depends. It depends on whether you need a challenge, you know, what type of challenge. If you got your own challenge, it's fine. But if you know, the contests do give you a little structure. So
I primarily flit like the bees flit.
Yeah,
from one to the other to the other.
Oh, that's good. That's good.
And a couple of things which kind of enamored me was the VS Code remote into the RPi, the platform IO, the visualization in ROS. Now these are things, and for example, the Oakley light, which I've also got. So in my flitting, the Discord server and this group is telling me where to flit. I really don't have a goal for a competition, and I don't intend to go for a competition. I really want to play around and learn.
You don't have to.
But it helps to have some goal, right? Because with all this, I mean, and it's, you know, 20 years ago when I got started, or 20 plus years, there wasn't all that much available, you know, to purchase and all the building blocks. But there's so much stuff available, so many options, so many boards, so many IDEs. Before you know it, you'll be spinning your wheel, just fiddling around with stuff, right? And trying the QtPy and trying this SDM board and doing this and that. And you haven't got, well, you've learned a lot for sure, but you haven't gotten anywhere, right? So it helps to have some goal in mind, right? Whether it's a contest-based goal or whether it's just a stake you put in the ground and say, I want to go in the square, right, and come back. But then stick roughly to that goal. Otherwise, you're just going to be bouncing around. Before you know it, you'll have tried 12 different boards and you still don't have a functioning robot, right? I think people have said it in different ways. You just put a stake in the ground, pick a board, see if it's physically kind of able to do what you want it to do, and then run with it for some time before you just try out something else, because I can get off on a tangent on my own, right? And start playing with different boards, and you know, the month will go by and I wouldn't have made any progress. Happens, right, all the time. So don't.
In fact, when you ask the question, and you were working with the RPi, you were looking at the LiDAR. What are you doing with the STM32? You didn't ask the question in that way. You were saying, what's your goal, Kumar? And I said, I don't have a goal. I had the goal to get the RP LiDAR working. Now my goal is to get the STM32.
Okay.
But the point is well taken, I think, which all of you are giving an input is, while you do this, keep a goal and make sure you are reasonably able to progress to that rather than just flitting. And I think that's useful to consider.
Small steps. And that's why I'm saying, first step, make yourself a tabletop robot. Otherwise, you go to your dining room table, knock off everything, put your robot on the top, and let it wander all over the top and not fall off. That's your goal. Do that. And then you'll find there's parts that you don't need, there's parts you do need. And then the next goal you do something that's got pieces that you need that you didn't have in that part, and just keep building. Yeah,
I would say that Doug and I differ on this. I never have built robots for contests. And
That's not contest. That's
when
not
I
contest.
find that, well, we had tabletop. When I
Yeah.
find a contest of interest, I look around at my robots and say, which one can likely do this? And, you know, would I have to add a sensor or whatever? But I would, just to back up what Chris was saying, the analogy I've used before is that, because I'm a musician, it's like, you know, picking up one instrument and learning how to play it a little bit, and then getting bored and picking up, and you never get good. You never get good on any of them because you're constantly moving from instrument to instrument. And, you know, really, whether it's a cello or a trumpet or a marimba, just pick one and learn to play it. And I see lots and lots of robots that are 2/3 of the way there. Nobody really, they had great ideas, but they didn't stay with it long enough to really learn how to play it, to really become a master of that instrument.
And that's actually been David's advice to me for what, 1.5 years, 2 years now, which I take seriously. I mean, on it, and we've had some emails just privately where David's been trying to beat me around the head to get some sense into me about not flitting around. And so this KR01 robot has been my main development platform for exactly the reason that David just reiterated, which is I'm trying to make this my main instrument right now. And I've got another robot in the Mars Rover robot, but that actually is going to take everything from the KR01 that I'm developing and just take it to the next level. But the KR01 robot I've been focusing on, and I've been giving and selling boards and getting rid of stuff that I didn't need, because I was doing that. I was buying all sorts of crap I had no plan for. But choosing an instrument, and it doesn't even matter whether it's a piccolo or a bass, or it doesn't matter. Just choose an instrument and stick with it. I totally think David's absolutely right on that. It doesn't matter which instrument you
I'm
choose.
going to play devil's advocate, because when I'm hearing here, you got the fundamental question of breadth versus depth, right? Breadth versus depth. And I hear a lot of arguments in the last few minutes about pick one and go deep. But I think that there's a time when it's productive and enjoyable to just dabble, just get your feet wet and all these other things. If that's what you want to do, dabble. At some point, if you want to go deep, fine. Now you've got your toes in enough of those that you can say, well, I'm going to go deep by taking this and this and this and this. And you'll have spend enough time dabbling and having fun all over that you'll be relatively confident in the choices of going deep. So I would argue that you can adopt anybody's philosophy that you want, but the only one that matters to Kumar is Kumar's philosophy. So Kumar, we support you whichever way you go.
And with that, I have two things to show. So I'll show you the base and not so base, because, yeah, let's see, a window. So
Carl, I don't disagree. In fact, my current development platform is number 4 of my robot.
So here's one platform you could work with, and notice this is a simple one. And it's not very expensive. You could literally put whatever board you want to right there in the front. It uses cheap motors. Okay, so there it has its pluses. It has a little sensor for a ping, so it could fire a line or whatever type thing. And it's relatively, as I said, very simple design, easy built, and you can put whatever board up in front. So that's
But Murray can't do it because it's 3D printed.
you can, yeah, but you can fold metal and you can cut it out wood. I mean, this is a basic design. I mean, effectively.
I like the wood idea.
Okay, so yeah, that's why I said you can shape a wood to hold it two motors, a reel in the back, which is a marble, can be. I mean, this design is out there. So that's why I said this is a basic design, but it has its benefit in the sense, okay, in fact, it's a variation of whatever one I have.
So what you're saying, Kareem, is this is only good for existing cult members.
That's right.
So that's the first one. Okay, and that's why I'm saying this is a basic robot. So that in that sense that, you know, it has two motors, a controller board of whatever in front. It could be a Raspberry, or it could be, in this case, it's an Arduino board, but it could be a Raspberry type thing. So that's the first one. In other words, I would go to Thingiverse and sort of look at all the different ones they have out there design-wise. So that's the first one. And since tonight we did talk about Ross a little bit, I have this I found. So, okay. So this is, in my mind, a little more sophisticated, but it uses Ross as a turtle bot lawnmower. So it actually covered a couple of things in the process. So you can see, and it has the radar on top. It has ping sensor. It has bumpers there. So yes. So this is the other one. So yeah, I haven't really see, and they have a get. So yeah. So here's what they get. So okay, in this case, it looks like about 2 years back is when they did the first attempt at Ross. And
Okay.
so there's, yeah. So from the very simple base to the not so base, but this, he has at least, information, knows the next steps and that. So, so for those who are more into the Ross, there's this you all can look at too. And so hopefully that helped. But as I said, the key is figuring out a real project. In fact, there's a little candy dispenser that you could maybe put like a ping sensor on that would, if somebody walk up, it would dispense candy. Since we're at Halloween, for example, if you want a base application that you could use with. So with that, I'll turn it over to how to, let's see if anybody else can get more confusion out there.
Okay.
I think Doug was next in queue, and we didn't have anyone with an update after Doug. So, Doug,
Okay.
take it away.
All right here. All right, guys, I'm gonna, I've made progress on my bumper. And I now have the bumper installed and work. Just to make sure everybody remembers this one.
Can you hold that up again, Doug?
I will in a second. This is what it looks like inside, okay? So it's got two bumper arms. It has rubber bands going to these 3 points. And it has two LED, IR LEDs, sensors and receivers going between here and here and here and here. And you might ask, well, where did you get those sensors? This is a real common board, costs about 90 cents. Unfortunately, you can't buy one. You usually end up buying 4 or 5 or 10. And here this is the photo transistor, is the dark one, and the diode is the white one. So I take these, unsolder these, and mount one in each of these two places. There's holes through these two bars. So now, let me shut that down. So if you, so this is what it looks like from the front. All right, so you can see there's very little gap. And if you watch, if I turn it on here, I'll probably try to go somewhere, but if you see this, you can see those two lights on each side. If you hit the bumper, one of the lights goes off. Now watch this, it goes off here, goes off here, goes off here, goes off here, a little more pressure there. But you can see that they're sensitive all the way around, and there are also very little gap between them. Let's see, anything else? So this is the actual board part is right here, mounted it. this does two things. It has a comparator, so it takes the analog signal off of the IR diode and the transistor and makes it digital, or sharpens the edges, I should say. It has no problems shooting the gap between that distance, and that distance is probably about it's less than 5 centimeters. Anything else to say about it? Oh yeah, two things. I figured this weighs about 3 or 4 ounces. I didn't weigh it before I put it on, and I haven't had a reason to take it off yet, so I haven't taken it off. I did two things. You can imagine you throw that 4 ounces on that lever arm in front of the wheel, change the balance. And sure enough, I had to put a 2.5 ounce wheel weight on the back to compensate. Now, the other thing that it did, which I didn't expect, was it also threw the PID controller off. The new weight. So it's not as responsive. PID needs to be retuned. So interesting consequences to making a change to your robot. So that's all I've really done this week. I've been working on the code because I want to integrate it into my existing framework, and it's working pretty good. So that's all I really have to show. Let me stop sharing.
That's pretty cool.
Yeah. Progress.
Looking good. Yeah.
It was on the list.
Something to feel good about without the distractions of club members leading you down other rabbit holes.
Yeah. Well, that one rabbit hole that Kumar's, I gotta try that. I just want to see it. I just want to see it.
So speaking of,
I'm not going to use it. I'm just going to see it.
Since I did, have the variation of it. That design I was showing you, this is basically a variation of it, only enlarged a little bit. So that's why I said, I have the bore up there, so I can put any bore I want. Doug's example of his, on the front, he has that where you can change out. So you could put a little pincher here or that. So, this is part of in designing the robot / what are you going to use it for. That's why I was saying you have to have some base goals plans. But, and this has a little spot where I could put the battery. And, it's a simple coaster, reel on the back. So this is an example of how you could build a base unit that you can modify. So that's why I was saying the key is trying to figure out, what bore, even though it really doesn't matter. The key is what you're comfortable with. And then how much documentation is out there or that. And that's why I would say approach it with that concept in a nutshell. Otherwise, you can't get too many rabbit holes out there because, from there you can get into 3 legs, 4 legs, does it walk, does it crawl type thing.
Cool. All right. Well, let's see. I think most everyone is given some kind of update. So just asking Doug D or Glenn or Kareem, anything to touch on this week?
I have
I've
nothing.
got
I've been
nothing.
busy.
I thought I saw Glenn trying to speak earlier, but his audio wasn't working.
Carl, I don't know if you missed it. Kareem also had some.
Oh, sorry, y'all couldn't hear me. Yeah, so I'm busy. I teach at the local community college Arduino and basic electronics to adults who sign up. So I actually teach an Arduino class and a robotics, the whole series of Arduino classes. And what I do is the last class. Can you see this one? This is your basic little robot, which consists of the idea was I teach the Arduino classes with the $50 SparkFun Tinker Kit. So I take it through like Arduino 1, Arduino 2, and then I teach a motor control class, and then I teach them to build this your basic little robot, but it had to be constructed without a soldering iron. And in the lab, I can't teach soldering in the makerspace yet. So it uses the $20 Shadow chassis from SparkFun, and all of the parts had to be purchased from one vendor, like SparkFun. So it's a SparkFun Tinker kit with everything, most everything used in the SparkFun $50 Tinker kit, plus the $20 Shadow chassis, plus a HR SR04 ultrasonic sensor, and then I teach 3D printing, so it uses a couple 3D printed parts to hold the 3D ultrasonic sensor on. So the kit, the SparkFun kit, also consists of a a photocell. So basically, the class is about teaching the students how to integrate the Arduino sketches, taking you from the motor control to integrate the ultrasonic sensor, and then use the light sensors. So what I do is have the students build a chassis, and then we work on the software. And the challenge is to make the robot roll across the makerspace with the light sensor, and like avoid, see how far you can get across the makerspace. So that's another. This is what I've been busy with. So I have a series of these here on my shelf behind me, various versions, and I documented it for the students to build. So that's what I've been busy with this last. I've been teaching this class for 5 years. So these classes. So I have these around, and I couldn't really change the class material much over the years. So just kind of stayed with the same SparkFun kit, but it works really well. For the students get quite a bit of kick out of building the robot and get it done in a 6-hour class. So it's pretty good.
Really like the idea of just moving across the space you have available.
Yeah, there's it's a maker space with 3D printers and equipment and stuff, and there's usually tables. There's the student workstations with computers, but there's tables scattered in the room. It's fairly big space. So when the robot goes around those, there's darkness, and so the idea is, program the Arduino to sense the light and just avoid tables, or the darker cabinets and tables in the room, and see if you can make it across the room. So it gives a basic introduction to Arduino programming and how to, just like a cockroach type of robot. So, but it's a light sensor type of thing. So a little goal attached to it, but I had to keep it to the $50 SparkFun kit. So, and no soldering. So I had to. That was the challenge: is how to have them constructed. And if I redesigned the class again, I would not use this shadow kit though. But it is you can snap it together without tools, but it can hurt your fingers if you're trying to unsnap the plastic back apart. So I don't like it, but it doesn't require any tools to assemble it. So it's kind of cool. You can even stick you stick the breadboard to the top, and really all you might need is really, you might use a pair of pliers, but in reality, you can put the whole thing together without any tools except a screwdriver to put the ultrasonic sensor on that, and I do have the 3-part glued down because I added that. But I'm sure there's
who wants to build the first cockroach robot that runs for cover every time you turn the lights on?
Yeah. Already done it. At one of our meetings in the old makerspace, and I can't remember who it was, but one of the guys that in the group at the time said, "All right, engineers, here's your challenge. You need to build a robot that only weighs a few grams, that can travel at high speed upside down across the ceiling, powered by breadcrumbs."
Mm.
Glenn, when we were back when we were meeting at the Makerspace, I had a challenge I had suggested, which was just when you walk in the front door, you put your robot down and see if it can make it back to the room where we meet. And I did that pretty much every time I showed up, but I never could get anybody else interested.
Yet.
I'll also say that despite the caveats, there's actually a lot of cool things you can do with light following and light avoidance. I had one of my robots out in the parking lot one night, set up to do, like to seek on a bright light. And so it spotted this street lamp in the parking lot, and it was headed toward it. But before it got there, there was a car in the way. So it turned, and it basically followed the shadow of the car. It swam along the shadow of the car until it cleared the car. Looked quite intelligent, and then headed back toward the light. And I had taken that same robot with my kids down to the local mall. Remember those? And set it down on the floor because they have so many little pools of light. And it was just fascinating to watch what it would do until the gendarmes showed up. And I don't remember their exact words, but it was something along the lines of, hey, we don't serve their kind here. You're droids. They'll have to wait outside.
Yeah, I think you could do a lot with just light sensors. I mean, you can make a flashlight be its remote control, make it follow your flashlight.
Exactly.
So you can do a lot with the light sensing on it.
Also, you need some kind of avoidance. I see you've got a ultrasound there or a bumper or something because the light behavior will pull you in.
A sensor on it.
Yeah, but the light sensor to attract you to things and some way to push you away from things, bumper or infrasound, you can do a whole lot of pretty fun things.
Well, somebody ought to start thinking of getting their robot to follow people.
I don't really want a robot following me.
You mean the stalker bot?
Yeah.
We've done that before. It's quite useful to have basically a Sherpa robot follow you around.
Can the robot have, or can the human have a beacon? Paul Bush.
We did it visually with a target slapped on the student's back.
That's a beacon.
I'll bet you could do it with OpenCV and have them recognize a person.
It's hard to recognize a person from the back.
I don't know. I had a girlfriend, but I'm sorry.
Paul had a project he was working on for a while where they wanted to be able to move trailers around at a depot with some kind of robotic truck. And my first question was, can we put a beacon on the trailer? And he said, no.
Mm-hmm. Well, I mean, if it's a person, it's not a chair. And as long as it's only one person in front of the robot, you can track a moving thing that doesn't look like a chair. So you can do it that way too.
Anything that's moving that has approximate dimensions of a person would work.
Exactly.
Well, we're usually doing this in the context of a robot competition when there's 300 students running around.
There's something from my experience sailing that I've always thought about. I've never gotten to the point where I could implement it, but in sailing, if you take a fix on another boat and then you wait a little while and you take another fix on that boat, if the angle is the same, if the angle remains constant, you're going to hit that boat. But if the angle changes, you're not going to hit that boat. So it seems like we ought to be able to do the same thing in robotics. The problem is that you're no longer talking about detections, you're talking about objects, which, as we all know, is a much harder problem.
I think aircraft pilots do the same thing. Put a mark in the windshield, and if the plane stays in the same location, you're going to hit the plane. Yeah. So. Yep.
Right. Well, we seem to have people dropping like flies. Anyone else with some last minute thoughts for the week?
or scurrying like cockroaches.
Scurrying like cockroaches as it gets darker and darker. Alrighty, I'm here and going twice, going 3 times. Gentlemen, have a great rest of the evening or day, and we will catch you in the next section next week.
Yep.
Bye.